Good morning, everybody.
Good morning, sir.
Right. Everybody can see the screen?
Yes, sir.
Everybody can hear me well. That's clear. All right. So I think this is going to be a very important session. As you all know, this year, CSEC will be marking only the multiple choice paper. So this session is very, very important. It becomes extremely critically important that you get a very high grade on the multiple choice paper, such that CSEC chooses to go the curve way to mark the paper. And what you'll find is that, you'll have to score a very high mark to get a grade 1, maybe like way up in the 50s to get a grade 1. Chances are also is that they will mark the paper on a scale basis, meaning chances are they will give the new questions a higher rating than their old questions. Because CSEC already knows that a lot of their questions are out in the public. All right. So the bottom line is that you all need to score very high. And when I say high, I mean like 58, 59, 60. Your aim should be 60 out of 60. So what I have here is a compilation of questions that I've put together over the years. There are a few repeats in there. I was trying to take out all the repeats, but there are still a few repeats in there. But this is a good spread of the various ways that CSEC can ask questions based on the syllabus. All right? The questions that you see in the exam won't be structured any differently from these. These are like the standard ways to structure multiple choice questions. And if you're lucky, well, you will be lucky to see a good number of them on the paper itself. I'm certain of it. All right, because the source for the questions are generally the same everywhere. All right, so I basically separated out the questions and try to give like maybe 5 to 10 years of questions from the same topic in groups. Right? So first group of questions will be a normal number theory questions, and then we're going to sets, and then we're going to consumer arithmetic, and we're going to functions, and they're all in groups. Right? Just as how the exam paper will be. The exam paper will be structured in groups. So for example, you see maybe 5 to 6 sets questions together. You see maybe 5 to 6 consumer arithmetic questions together. All right. So
Yes.
the session is being recorded. It's online, and so when I'm done, you can always go back and watch that recording. To look back at any of the solution, anything you don't maybe understand so clearly, you can go back and have a second look. Anything that you want to review, it will be there online on my channel. Channel is my name, and persons who are here in this class should basically have that information. All right, so we're gonna go straight into it. Remember, you cannot use a calculator in the exam, guys. You cannot use a calculator, and therefore you have to be smart. Remember, the answer is on the paper. The answer is right there in front of you, and oftentimes we tend to try to do the questions without, just looking at the answers. And sometimes we can know what the answer is without actually working out to completion. A lot of times you don't need to complete the working out to know what the correct answer is, because the answers are there and you can easily eliminate some. Sometimes you can eliminate 3 of the answers and know what the correct one is without fully working out the question. So you should always pay attention to the answers. Oftentimes as well, you can use the answers, use a method of elimination, use the answers to decide which one is correct. So it's like you're plugging the answers back in the question, like a reverse calculation, All right, so we look at all those methods here, that we can use to do these questions. All right. So at the end of the day, you want to do the questions as quickly as possible, because you don't need to show working for the multiple choice. You just need to get to the correct answer as quickly as possible. All right. So the first question here is this one. And it says the digit 2 in this number has what value? What is the value of the digit 2? Let me reduce the print size a bit. Hold on a second. All right. So this is the digit I'm talking about, this digit. So that digit is 2 places after the decimal point. And so really it is 0.02. And 0.02 is the same as 2 divided by 100. And so simply put, that is the answer. Simple as that. So extract the value that it is in its place, 0.02, and it is 2 over 100. All right? And we're moving down. What percentage of 50 is 10? We can set up this like an equation and solve it. But then we can use a sort of shortcut method to do it. What percentage of 50 is 10? Now, you can break it down, you can break it down and say, okay, first the 10% will be equal to 5. 10% will be equal to 5. But you really want 10. And therefore, it must be that you double this to get the 10. So therefore, 20% is 10. So the answer is 20%. All right? That's one way to do it. You could also do it like a calculation. You can say, okay, what percentage of 50 is 10? So you can say, okay, x over 100 times 50 is equal to 10. And you're trying to find the x. You can set up like an equation like that as well. And you can set this down. So basically, it will be 50 into this 1 time, 50 into this 2 times, and you're multiplying this 2 across here. All right? And so you would get that the x equals 2 times 10. So the x is 20. That's another way to do it. But we know we can build up the percentage as we did there as well. All right? Next question. So if you notice, there are 2 questions here. They ask us to write that in standard form, standard notation, also called scientific notation. And in this question here, you see basically the same values or the same digits, 2086, but the size is different, right? And that's on another, this is on another paper, right? So the thing is, this is going to be a very small number because it is 0 point something. And with a very small number, usually it is 10 to some negative number of decimal places, like for example, this one. Right? This one now is a large number. In this example, this is a large number, right? It's 200, and so it's 10 times 10 to some positive number of decimal places. So I would say maybe this one or this one. But what do you know? You basically want to get the decimal point right here. So to get the decimal point right there, you have to multiply first by 10 squared to move the decimal point for you. But then now to balance out the multiplying up by the 10 squared to move the decimal point, you have to cancel that by multiply by 10 to the negative 2. So this calculation here will move the decimal point for you to where it is supposed to be. Because scientific notation, the decimal point comes 1 place after the first non-zero value in the number. Right? So there's always a number in front of the decimal point, and then you have the digits following. That's what you want for standard form. All right? So the value between 1 and 9 in front of the decimal point, and then you have the rest of the number. So you always want to get the decimal point in front of the first digit or after the first digit, first non-zero digit. All right? So this calculation will move the decimal point to where we want. And so it will become 2.086. And then you put back this times 10 to the minus 2. All right? And so that's why this one is the answer here. In this case, we want the decimal point again. Let me use already. We want the decimal point to come back to the left, to here. So in this case, we move the decimal point to the right to get it to where to come after the 2. In this case, you're moving it to the left. So because you're moving it to the left, you're dividing by 10 squared, or you multiply by 10 to the minus 2. So to move the decimal point, we'd have to multiply this number by 10 to the minus 2. That's what we'd have to do with the number, to move the decimal point 2 places to the left. But to balance out that, to cancel out the multiplication of that by 10 to the minus 2, you have to multiply it by 10 squared so that the value remains the same. And here now we have the calculation that move the decimal point for us. And so it will be 2.0806. It should have a 06 on it as well. And then this times 10 squared. All right, and that is just to show some working. But as I said before, this was a small number, so it must be times 10 to the minus something. I know you know what something is. It's the number of decimal places that you have to move the decimal point. And this now is a large number, and again, it's 10 to a positive power. A number times 10 to a positive power. What is that power? What's the value of that power? It's a number of places that you have to move the decimal point to get to the way you want it, and those 2 places. So that's why that is the answer. So you can look at it that way as well. Nice and easy. All right? We'll come to this question. In a school, the ratio of the number of pupils to teacher is 20 to 1. So it's 20 students, 20 pupils to 1 teacher. It says if the number of pupils is 840, how many teachers are there? Now, I always say to the students that a ratio is really just a broken down, like a breakdown a big fraction into small fractions. So like it's a broken down ratio of the actual numbers. So because this is a broken down ratio of the actual numbers, what you can do, you can build this ratio back up to the actual numbers by multiplying it back up. So the ratio teacher, no, not one teacher, it was pupil to student, pupil to teacher is 20 to 1. If I can build the teacher, the pupil side back up to 840, then I will know what this side is. And this can be easily built back up to 840 because I already have the 0 here. So it's really the 2 that I need to build up. I need to build the 2 up to 84. To build the 2 up to 84, I need to multiply by 40. Simple as that. So if I multiply this ratio by 42, then the number of pupils will become the 840 that it actually is, and the number of teachers is 42. So the answer is 42. Simple as that. And the reason I do it this way, because there are some questions that will ask you for different things in the ratio, like the difference of 2 values or the sum of 2 values in the ratio or something like that. So I like to do ratio this way, where you're multiplying or dividing to get the value that you want. You're trying to reach the actual values. Can you mute your mic, please? Keep your mic muted, please. Please keep your mic muted. Hold on a second. All right, so that is that one. Well, here's another question. I think there are other ratio questions on the paper. I wanted to put all of them together, but no problem. We'll get to them. This is another question. It says a bag of apples can be shared equally among 6, 10, or 15 children. Can be shared equally among 6 children, can be shared equally among 10 children, or it can be shared equally among 15 children. The minimum number of apples that are likely to be in the bag is what? It has to be the lowest common multiple of these. You want a multiple of those because those are that number you want to be able to divide it by 6, or you want to be able to divide it by 10, or you want to be able to divide it by 15. All right, I remember the answers are there, and you don't have to calculate it. You can just look and see which one it is. So the first one here, which is the smallest one, is 30. But 30 is a multiple of 6, it's also a multiple of 10, and it's also a multiple of 15. So that's the answer, you know. Simple as that. So you're looking for the lowest common multiple. So let me write LCM. It is the LCM of the 6, the 10, and the 15. That's what it is. And that is equal to 30. That LCM is 30, lowest common multiple. And as I said, because the answers are there, I don't have to work it out. It's right there. So I use a process of elimination. That's the lowest one in there that is a multiple of the 6, the 10, and the 15. This is another way of writing the same question. It's the least number of apples. Hope you can see. Not so clear. The least number of apples that can be shared equally among either 6, 10, or 15 children. So this is the same question. This is really the same question right here. This is the same question, just written a different way. Same question. All right? Written a different way. So, you might see it worded like this. It's the same thing that I asked you. All right? So that's why I put that right there. So the answer is 30. But you can just look in the answer and look for the lowest common multiple. All right? And that is that. All right, next question. This one is similar to the one that we did over here. Right here. What percentage of 50 is 10? No, it's what percentage of 40 is 8? What percentage of 40 is 8? And we can use the same approach again. We can say 10%. 10% of 40 is actually equal to 4. I take off the 10, take off the 0, which is 81. So if you want it to go up to 8, you want this to go up to 8, you have to multiply by 2. So we can say, therefore, 20% is going to give us the 8. 20% is going to give us the 8. And so the answer is 20%. So we can just reason it down like that. Mute your mic, please. Mute your mic. Mute your mic. Keep your mic muted, please. Really. All right. This next question now. They want us to, they give us this information that is equal to that. And then they want us to work this out. So again, what you can do is count the movement of the decimal point. So this number really is adjusted to that. And this number is adjusted to that. And the net adjustment of the decimal places is what you can move this by. Right? That's one way to look at it. Now, I can look at these numbers and get a quick estimate. Because this number is approximately 0.5, half. So it's almost like I'm doing half of 24. So the answer is approximately 24 times 0.5, which is half. So it's approximately 12. So I could look for the nearest number to 12, which in the answer is this one. So I could do it that way now. Can do it that way. Right? So let me leave that way on the sheet. I'm going to leave the 2 ways. So I can say this and do 2 ways. I can say it's approximately equal to, this is approximately 24, but I know it's more, right? So I'm rounding the values up. So the actual answer is going to be less, right? But these numbers are sufficiently different in size, right? This is at tens, this is 100, this is thousands, and that's 10,000. So it's sufficiently different in size for me to estimate the answer. So this value is approximately 24 times. This value is approximately half, 0.5. Which approximately the answer would be 12. So the answer is approximately 12. So the best answer, the closest answer to 12, which is less than 12. Why less? Because we rounded up these 2 values. The closest one is this one. So we could determine it that way. Or we could count the decimal places, the movement of the decimal places. Mute the mic, please. So let's look at it. From this to this, the decimal point move 1 place back because it is like here. And they move 1 place to the left. So when they move to the back, it's like you can put a -1. The minus means you're moving to the left for the decimal point. This represents the movement of the decimal point. And this one, to go from this to this, it moved 2 places to the left. It is right here, and it moves 2 places to the left right here. That's another 2 places you move, -2. So we therefore need to move this. We can put an equal here. We need to move this to get the answer. We need to move it a sum of 3 places to the left, -3. So if we move the decimal point 3 places to the left, 1, 2, 3, the answer is gonna go, let me show it, 1, 2, 3, 1, 2, 3, the answer is gonna go right there. The decimal point is gonna go right there. That's a -3 places. So the -1, the -2, and the -3, you're adding this, you're summing the movement of the decimal point. And you do that when you multiply values, guys. You do that when you multiply values. So that will show me that the answer is 11.4445. If I count the net movement of the decimal point. So I could get the answer that way. Similar questions can be done that way. There are a lot of questions set that are similar to this one. We can work it out using an estimation method if the values are, can be estimated, can be rounded up or down like that. Or you can count the movement of the decimal point. All right, the net movement of the decimal point. All right, so that is that. And this one now, well, the distributive law, I like to call it distributive law, factorization law. It's really about factorization. Distributive law is really about factorization. That's what it's really about. Factorizing and expanding. It's about factorizing and expanding. Factorizing and expanding. That's what it's really about. That's the bottom line of the distributive law. So basically you have these two, and you really want to just factorize them, right? Because it's about factorizing. So they are right now in an expanded form. You want to factorize it. So you're looking for the highest common factor in these two numbers, which is the 49. So it's a 49 multiplied by, and then you would multiply by the 7 plus the 3. 17, sorry, plus the 3. 17, let me put the times. Times 17 plus 3. So like a factorize it, and the 17 plus 3 is 20. So it's 49 times 20. Or you can look another way. You have 17 49s plus 3 49s. 17 and 3 make 20 49s. This is the 20 49s right here. 20 49s. That's what it is. That's another way to look at it, guys. Simple as that. All right. This one now, again, is distributive law. I don't want to know which one of these is the answer. If you notice, the 99 is coming back in all the answers. Right? So we're going to keep the 99. We're going to break up the 100. So this value is the same as 99 times, break up the 101 into 100 plus 1. And then with the reverse of the factorization, which is the expand, another distributive law question is really. So it becomes the 99 times 100 plus distributing the multiplication over the addition. You can distribute multiplication over addition. So you distribute this multiplication over the addition, and so you get plus 99 times 1. That's what they're looking for. 99 times 100 plus I distributed the multiplication over the addition. So the addition symbol must come between them. And all I need to do is put in the bracket here, and it will match the last one with the plus right there. You have to be careful. This is the last one. That's the correct answer. It's easy to select the wrong answer here now, guys. Easy. So you have to be careful. All right? That is that. This question now, decimal places. We are to correct this number, that number, correct the 3 decimal places. All right? Written, correct.
You can't drink what?
Mute your mic, please. Mute your mic. So we need to identify the 3rd decimal place. So this is the 3rd decimal place.
Sir, B.
No, I don't want you to tell me the answer. I'm working them out. Okay? You can just keep it in the mind. If everybody's going to show out the answer, we won't make any progress. So if you know the answer, that's good. That's fine. All right? We can't go into calling out the answers. All right? That's not what this session is about. All right. So we're going to correct that 0. We're going to use this 6 to correct the 0. So because the 6 is a value greater than 5, but normally once it's greater than 4, once it's 5 or more, it will increase that preceding value by 1. So increasing that 0 by 1. So that's why the answer is correct, as we said, B. It becomes 3.141, which is B in B. So that is correct. All right, let's continue. All right, so that finishes page 1. All right, but it goes so far. A lot of pages in this document, guys. About 60 odd
Yes,
pages.
sir.
All right. Let's continue down here. So this is a sequence question right here. This one. So what you have to do is you have to basically observe how the values are changing. Let's look at it. Well, clearly, to go from 1 to 6, you add 5. So we added 5. Let's put the 5 there that we added. To go from 6 to 13, you add 4 to reach 10, and then 3 more to reach 13. So you're adding 7. 4 and 3 is 7. Then to go from this one to this one, I'm putting what we're adding in between this, right? To go from this one to this one, you're adding 9. Because like you add 7 first to reach 20 and then 2 more. So you're adding 9. So you must cancel the trend. You keep adding 2 more than the time before from number to number. So clearly, that's why they added 11 to go from 22 to 33. You're adding 11. So if you're adding 11, your next addition must be 13. We must add 13 as our next addition. So the 33 plus 13. So the answer here is 33 plus 13 right here. It's going to be 33, and you add the 13 plus 13. That is 46. So the number here is 46. 46. So the answer is 46. All right, that is simple, straightforward. So these are what you're adding from value to value. That's what I've placed here. At 5, then 7, then 9, then 11, and clearly the next value to add is 13. All right, that is the answer. This one here, prep school question. 0.45 written as a common fraction in its simplest term. So 0.45, we normally write it as 45 over 100 first. So 0.45 is the same as, is equivalent to 45 divided by 100. And you basically just cancel this down, divide it down. Divide it down. We can divide the 45 and the 100 by 5. Divide each of them by 5. So divide each of them by 5. Right? So it's like you divide this by 5 and you divide this by 5. Just to show some work. Right? We could just cancel it down by 5. But I'm just showing some work. You divide the numerator by 5. You also divide the denominator by 5. All right, so the final answer is that the 45 divided by 5 is 9, 100 divided by 5 is 20. I could just use a cancellation, so we could do a bit like this. So we can cancel out 5 into this goes 9 times, 5 into this is 20. The traditional way. Anyway, take it, the answer is 9 over 20. That is it. All right, easy question. So let's set these questions on exam as well. That's another ratio question here now. So this question says a certain amount of money is shared in a ratio 2 to 3 to 9. 3 parts. It says if the difference between the first and the second share is 40. So this is actual, you know. This is just a broken down ratio of the actual numbers. My approach is to build it back up to the actual numbers. And what they're telling me is that the difference between the first 2 values is 40. So look how I'm going to write out the ratio. It's asking me what is the amount shared. So that is my total. Here I'm trying to find the total. All right? So look how I'm going to approach it. And I'm approaching it this way for the purpose of doing other questions that might ask more complicated. Mute your mic, please. Mute your mic. So it is 2 to 3 to 9. That is the given numbers. I'm going to put in another part, which is the difference. I'm going to put in a part for the difference that they told us about. The difference of the first 2 numbers. Let's call it diff. 1. And I'm going to put in a part for the total. I'm going to put in a part for the total. And the total right here would be 9 and 5 is 14, right? 9 and 5 is 14. That's my total. They told me that the difference is actually 40, so I want the difference to be 40. So if the difference is going to be 40, I need to multiply the ratio by 40. So if I multiply overall the ratio by 40, because I want the difference to be what it is supposed to be, then I need to multiply everything by 40, including this. And that's the answer that I want. And I want to know what the total is. So now multiply by 40. This by the rate. This becomes the 40 that the difference actually is. 2, and then I need to multiply this by 40. How do I multiply that by 40 quickly? 40 times 14, or 14 times 40. Put it side by side so you can see it again. So in the exam room, I want to work this out quick, right? 40 times 14. You can apply the 0 first. I get 140, so it becomes 4 times 140. And then you do 4 times, you do the 4 times the 140, right? But you can also break it down and say, okay, 40 times, the 10 times, 10 times, the 14 times 40, just as we did a while ago, is actually 10 times 40 first, that's using the 1, plus 4 times 40. Break it down that way. And the 10 times 40 is clearly 400. And the 4 times 40 is clearly 460, 160. So it adds to 560. So you can do it that way quickly. You know, break it down and do it that way. So this becomes 560. So this is the answer right here, 560. Remember, you cannot use a calculator now, guys. So you need to develop the quick methods of doing the multiplication and stuff, right? Whether the numbers big or small, you need to develop some little quick ways of doing these calculations. Let's leave that in green. No, undo. All right, so that is it. So the answer is 560. So this is the approach I like to use that I just did. All right, this is not the only way to do it. Don't get me wrong. But you know, this is the approach I like to use because I want to see what the actuals are. Because sometimes they will ask you other stuff. So I like to see what the actual values are. So I usually build my ratio back up to what the actual values are. And then we'll know everything. Right? You can answer anything once you know the actuals. This question right here now. This question we must recognize that what we are going to use is the difference of 2 squares. So you're not going to work this out and work this out in the exam. You have to recognize that that's the difference of 2 squares. So it actually becomes equal to the square root of the difference, which is 17 minus 15, times the sum, which is 17 plus 15. So this here becomes 2, so it becomes equal to the square root. This is 2 times, and this right here is what? What is that? 32. And then the 2 times 32 is 64. And everybody knows the square root of 64 is 8. All right? So that's what it is. You have to recognize this as the difference of 2 squares. Difference of 2 squares. You approach it that way. All right? If you know the perfect square for 17 and the perfect square for 15, well, fine. You can do it that way as well. And then subtract them and get the 64. But I think this is the easier way to do it. Recognizing the difference of 2 squares. Remember, in a CSEC, you know that you can use a calculator. So if it is a question, you feel as if it requires some expensive use of a calculator, you know that you're not using the best method. Right? You're not using the best method if it requires some extensive use of a calculator. Right? Generally speaking. All right, next question over here. These are all first part questions, like on the first page of your exam paper. You see questions like these. All right, this one now. Negative 3 square becomes a positive 9. Negative 2 square becomes a positive 4. So this becomes 9 plus 4, which is 13. Positive 13. Don't give it away. Negative is under the square root. If you see negative 3 square like this, if they give it this, negative 3, and they put the square out there, minus, like that, and then they put 2 square. These negatives are not squaring, so they're going to stay negative. So this will become negative 9 and negative 4. That case, that will be negative 13. So that's how you could maybe get a negative 13 answer if you had something like this. All right, but we're answering the question. All right, next one, which is straightforward. What number must be added to 1 1/3 to make it 2? So 1 1/3 is the same as 1 plus 1/3. 1 plus a third. You need to add another 2/3 to make that into 1 so that you can get 2. Simple as that, you know. 1 plus a third. That's what 1 1/3 is. So to make it 2, we have to add a 2/3. So if we add a 2/3 to this, you see 1 and 1, 1 and 2 is 3, 3 over 3 is 1. That is when this becomes equal to 2. So we have to add a 2/3. All right. So the answer is 2/3. All right. Next one. So we have this to divide by that. All right. All right. Show you a quick way we can do this now. We can actually set it up as a division and move the decimal point and the denominator to make it 1. But this is the same as 11.1 divided by 0.01. So if I move the decimal point under here 2 places to the right, then I have to move it 2 places to the right up here as well. All right. So it's like I multiply the numerator by 100, I multiply the denominator by 100. Right? So it's like I multiply up here by 100, I multiply under here by 100. Why did I multiply under here by 100? Because I want the denominator to become 1. So that will move the decimal point for me 2 places to the right. So the numerator will become 1, 1, 1, 2 places to the right, 1, 2. So put another 0 over 1. So the answer is this one, the last one. We'll mark this one, you know. The answer is this one, 1, 1, 1, 0. 1, 1, 1, 0. So the last one is the answer. That is it. And then the bracket here, the box here is another question, very similar, almost the same thing. Just that instead of 1, 1, 1, 1, they gave us 2, 2, 2, 2. So the approach can be the exact same thing that we just did a while ago. We can again put the 2, 2.2 over the 0.02. Move the decimal point to the right. You want to get rid of decimal point from the denominator. So you multiply under here by 100 to move it to the right. Multiply up here by 100. And what will happen again is that the numerator will become 2220 and the denominator becomes 2. Then now you can divide out the numerator by 2, by this 2. Right? And so it comes back to the same thing, 1, 1, 1, 0. So really it's the same thing. So basically the same question, you know, just written in a different way. It's really the same question. All right, and that's what you'll find. All right. This next one down here. It says 12.5% of a sum of money is 40. What is that sum of money? 12.5% of a sum of money is 40. The answers are on the paper, you know. I can actually test these answers, you know. I can estimate them, you know. 12.5% of a sum of money is 40. What is the sum of money? All right. But you can actually work it out and try to get a closest point where it's 12.5 is 12.5. So I'm going to write it like this. 12.5 divided by 100, that's 12.5%, times a sum of money, which you don't know. Let's call that sum of money X, is equal to 40. And we can set it up as if we're solving that. Right? We can set it as if we're solving that. You know, we can multiply the 100 over here and divide by the 12.5. Right? So the X becomes 40 times 100 divided by the 12.5. Cancel it up that way and cancel it down. All right. I can move the decimal point to the right again, add another 0 to this. All right. So I can multiply here by 10, but I don't like the decimal point. I multiply up here by 10 again. I run out of space. Let me just a little smaller. All right, just to simplify it down, just to eliminate those decimals, and then I will get 40. Basically, get 40,000, right? I can put 40 times 1,000 divided by 125. And here cancel down. So we can divide this by 25 and divide this by 25. All right, we can leave the 100, we can leave the 100 and put the 10. So That's all right. 100 times 10. And you cancel down. Divide by 25, divide through by 5, all of that. So this divided by 25 is what? We're dividing through by 5. Somebody tell me, this divided by 25 is what? How many 25s are in that? 5 of them, don't it?
Yes, sir.
Right, so 25 into this, so we're dividing by 25. So we're dividing by 25, the numerator and the denominator. So this becomes 5, and this becomes 4. All right, this becomes 4. They want to divide by this 5 now. So 5 into this 1 time, 5 into this 2 times. So it is 4, 4, 16, 16 twos, 32. So the answer must be the one with 32 in it, which is this one. Must be this one. So we have to work it down to completion. It must be that. Right? So we can set it up like that and cancel it down. Right? So I set it up like an equation that I want to solve. I'm trying to find it. 12.5%, like 12.5 is 12.5. And the sum of money equals 40. Then I transpose to solve for the x. Multiply by 100, divide on the 12.5. I don't want to be working with those decimals. So I multiply by the 10 to move the decimal from out of this, multiply numerator also by 10, and then we'll just cancel down. Cancel it down, cancel down the values. All right, if you see bigger numbers, you can use to cancel it down, well, fine. No problem. All right, no problem. But that is it. 220. All right, next one. It says a test was marked out of 80. A test was marked out of 80. A boy scored 60% of the marks on the test. How many marks did he score? He scored 60% of the 80. So you want 60% of 80. So you want 60 over 100 of 80. That's what you're calculating. It must be the answer with the 4 and the 8 only. So I don't have to work it out. The number that are materially important in this calculation is the 6 times the 8. But the zeros going to do their own thing and cancel each other. The zeros will do their own thing. Materially, the values that are of interest in this calculation, based on the answers that are here, is the 6 and the 8. 6, 8 is 48. So I don't have to can't work it down. 6 times 8 is 48. So this must be the answer. That must be the answer. I don't have to work it all the way down and cancel down the zeros. I don't need to. You don't have to work it all the way out. Let's look at the material number, the number that are significant in this calculation, the 6 and the 8. 6 times 8 is 40. Right? So the only value there with that 48 is that. So that has to be the answer. All right? All right, next one. There are 40 students in a class. Girls make up 60% of the class. 25% of the girls, remember, 60% of the 40 are the girls, right? And then 25% of the girls wear glasses. And I want to know how many wear glasses. You can set it up like this. 25 over 100 times the girls wear glasses. How many girls are there? The girls are 60% of the students. So you can set it up like this now. So it's 25. Now 25% actually is just a quarter, right? It's a quarter. This is a quarter. 1 over 4. So I can write this as 1 over 4 now times. And what are the girls? The girls are 60%. 60 over 100. 60 over 100 times the 40 students. That's what they calculated. Eh? So look at these numbers now. I don't have to work it all the way down. This 4 cancels this 4. So the only value of importance there is a 6. So looking for the answer that has a 6. It has to be the first one. I don't have to finish it. It has to be the first one. That must be the answer. I don't have to finish it, but it worked down still enough because you cancel it all the way down. Cancel down this 0 with this one and this one with this one. You see that the answer is 6. But once I reach there, I don't need to work out everything because this 4 cancels away that 4. So the answer must be 6. All right? But understand that calculation that I just did? But understand this calculation?
Yes, sir.
Yes, sir.
All right, cool. All right, next question. So you didn't have to calculate the actual number of rows first. That is the point. All right, let's make it into one expression and cancel it down. All right, so that finishes that. All right, so we're done with page 2. Then we come to these questions here now. I want everybody to pay attention to this one, right? So these 2 questions are very similar, and a lot of people swatting past paper questions. What this one has a positive 2 on it. This one has a negative 2 on it. Well, plenty of people will see this one and believe this is it. Huh? Plenty of people will see that one and believe this is it and go and mark the wrong answer. But then the answer for this one is 4/9. You see, the 4/9 is also here, but this is wrong. So we have to be careful as we put these 2 questions side by side. All right, so we have to be careful. So the negative, generally speaking, means reciprocal. Means that you're going to flip the fraction. That's what the negative power means. In simple terms, it means reciprocal. So this one actually is the same as you're going to flip the fraction in here and then drop the negative power. So it becomes 9. I'm going to put a 9. It becomes 3/2. 3/2. And then we'll put on about the square. So I want us to understand that what it means first. That's what the negative does. The negative power does the reciprocal. And then we can square each value now. Because the 3 is under the square and the 2 is under the square. So it becomes 9/4. So the answer for this one is this, 9/4. So this one now, we can square this one as it is. Square the 2 and square the 3. You square the 2, you get the 4/9. So this one becomes 4/9. 4/9. So the answer is still D, but you have to be careful and look out for these small changes with the questions. All right? Look for those small differences with the questions. All right, next one. Here, oh, this is a repeat. So this is a repeat. I'm going to repeat beside this. This is a repeat question. So I'm going to put R beside this for repeat. And I'm going to clean up the document. I'll know that that's a repeat. But this was the answer. We did it before. Correcting this one is correct. Is the 0.141, which is this one. So we did that a while ago. That's a repeat. And so we'll come back to this question again. But what I did earlier was put this question beside the one that was 0.020806. Put them together. You can see it. Right? With the mind. So again, what it is that to get this in scientific notation or standard notation, or standard form, I mean the same thing. We need to get the decimal point. We need to get the decimal point right here. Right here. So to get it there, we need to move it 2 places to the left. We need to move it 2 places to the left. How do you move it 2 places to the left? By multiplying the number with 10 to the -2. The -2 power will move it to the left. So that's what we have done so far. What we have done so far is multiply by 10 to the -2 just to move it to the left. We have to cancel out or balance back out that multiplication of 10 to the -2, which is to multiply by 10 squared, 10 to the +2. And so this calculation in here will move the decimal point and put it where we want it, right in front of the 2, or right after the 2. So it becomes 2.0806. And then this comes back as times 10 to the 2. Again, another way to look at it, just realize that this number is in the hundreds. This number is in the hundreds and the 200 and something, you know, so it must be a positive power. This thing usually show what it is, you know, the size of the number. The number is in the thousands, it's gonna have 10 cubed. The number is in the hundreds, it's gonna have 10 squared. The number is in the tens, it's gonna have 10 to the 1. If the number is in the 10, it's gonna have 10 to the -1. If the number is in the hundredth, it's gonna have 10 to the -2. Right? So the 10 to the something here really is about showing the size of the number. And this number is in the hundreds. This number is in the hundreds. So that's why I multiply by 10 squared, because 10 squared will bring it into hundreds, bring this into the hundreds. All right, I'll keep it in the hundreds. So that's why this is the answer. It's another way to look at this thing. Scientific notation. All right. Next question. All right. So this one is another ratio question. It says 560 is shared in the ratio 2 to 3 to 9. Again, this is adding up to 14, right? It says the difference between the largest and the smallest share is, what's the difference between the largest and the smallest share? Now I could use a ratio and say the total is 14. 14 parts total. The difference between the largest and the smallest is 7. So it's 7 out of the 14, you know, times the 560. We'll do it that way. It's basically half of 560, which will be 280. So answer is 280. But again, I like to do the question where we show the actual values. So let me just show you that method again, just in case. Let me write the two solutions. I'm going to write it up here. I'm saying the difference is the 7. So it's 7 out of the total of 14 times the sum, right? That's the difference of 560. That will be equal to 280. Right? That's the difference, because it represents the difference. It's like you calculate the value for the 9 and calculate the value for the 2 and you subtract them, but they are out of the same total. That's why you can just put the 7 over 14 to get the difference. The largest portion will be the 9 portion, the small portion will be the 2 portion, right? But if I were to show the actual values, what is it? If I were to show the actual values, it will be 2 to 3 to 9. And the total, I'm going to add a portion for the total, which is 14. This is my total. To see what the actual values are, I need my total to reach 560. So the question is, what do I multiply 560 by to get it up to, what do I multiply 14 by to get it up to 560? We can go gradually now. We can carry it up by 2 first to 28. Right? And then carry it up by 2 again to the 54. So we can carry it up by 10, and then to become 140, and you multiply everything by 10. And then you multiply by 2 to carry it up to 280, and then you multiply by 2 as well. Right? So you multiply by 10, you multiply by 2, and you multiply by 2 again. Right? By 2 again. But you can just multiply by 40. Right? Because it's basically 10 times 2 times 2 again. Right? So you could just multiply by 40. And you see that it's really 560. So I'm saying if I multiply my ratio by 40, then it will show me the actual values. This will become the 560 total that it actually is, 560. Right? And then I'm multiplying these by 40 as well. So the smallest share become 80. This share become 120. And this share become 360. Multiply by 40. You see the difference between these two. The difference between these two is the 280. Right? So the 280 is the same answer, but this is a quick way to do it. But I like to show this method as well, so that if they ask you more complicated things, you can know all the actual values. Right? So this is the answer still, 280. So remember, the ratio is just a broken down. It's just the actuals broken down to the smaller values. That's what the ratio is. And so you can multiply the ratio back up to the actuals and see what the actuals are. Here another question inside here, similar question. 350 is shared in the ratio 2 to 5, 2 to 7, 2 to 5. So you know the total is 7 parts. What's the smaller share? Smaller share is 2 out of the 7. Total part is 7. And the smaller part is 2. So I'm going to do this one the simple way, which is 2 out of the 7 of the 350. All right. So basically that's 70 because 2 times 350 is 700. 700 divided by 700 divided is 100. No, 100. 100. Yeah, 100. 100 is the answer. 100. Let's make sure. 7 to this 1 time. 7 to that 5 times. Yeah, 100. So the answer is 100. That goes to 2 times 350 is 700. 700 divided by 7 is 100. So that answer is 100. Smallest share. All right. Here's another question. This question says 60% of a number is 90. What is 4/5 of the number? 60% of a number is 90. What is 4/5 of that number? You can find the number first if you like, and then calculate 4/5. Right? We can set up like this. 60% of the number is 90. So 60% of the number is 90. So I'm gonna say, all right, 60 over 100 times a number is equal to 90. All right. So the number equals, I can cancel these values down. So cancel this, cancel that. Right, and this can cancel as well. 2 into this goes 3 times, 2 into this goes 5 times. That's 3/5, right? So can multiply the 5 away and divide on the 3. Right? So the number can become 90 times 5 over 3. But I really want 4/5 of the number. I want 4/5 of the number. And I didn't have to move this 5 either. Since I want 4/5 of the number, I didn't have to move this 5. I want to just move this 3. In fact, let me put it back. I'm not going to move this 5, but since I want 4/5. So right now, 1/5. Let me shift this down. If I move the 3 alone, then I'm left with 1/5 of the number is this, which is 30. 1/5. No, this is a 3. Sorry, this is a 3. No, I go back to it again. So this is actually 30. But then I want not 1/5, I want 4/5. So I need to multiply this by 4 again. So multiply this by 4 now. To get the 4/5. So this becomes 4/5 of the number becomes 4 times this 30. Becomes 4 times 30. Which is 120. So the answer is 120. I mean, it's not the only way to do it. But I'll set up like an equation. If you wanted, you could find out what the number is first and then calculate 4/5 of it. But the thing is, you can find it along the way. That's what I did here. I found it along the way. So I've set up the 60% of a number equal to 90. It's like I'm trying to find a number. Because I want 4/5, it was convenient to leave the 1/5 here and just divide on the 3. So when I divide on the 3, then this side becomes 30. 90 over 3 is 30. So I know 1/5 of the number is 30, but it's 4/5 I want. So then I multiply this now by 4, so that this becomes 4/5. I also multiply this 30 by 4 right here. And so that's how we get the 120. That's not the only way to do it, but the answer is 1.
What? You want to see my face?
Mute your mic, please. Mute your mic, please. Mute your mic, please. All right. That is that. All right, let's continue here. There's another question very similar to this, almost the same thing. Notice this one, the numbers are 60%, 90, but still 4/5. 60% and 90. Over here now, it is now 30% and 45, and I still want 4/5. So we can set up the same way again. Why do it another? Why do it a different way? 30% of a number is 45. What is 4/5? Set up the same way. So 30 over 100 times a number equals 45. And I want 4/5. So this cancels down again. 1 into that. Well, the 3 can't move now. No, the 5 can't move. I can multiply the 5 across here. I can divide both sides by the 3. So I can divide this by the 3, get 1, and divide this side by the 3 and get 15. Then I multiply across the 10. So I multiply across the 10, the number becomes 150. But understand that? The number becomes 150.
No, sir, I don't understand it.
You don't understand? All right, let me see if I can explain again step by step. All right, so I'm writing up an expression for this. First, they say 30% of a number is 45. I don't know the number. So I'm going to put it like an equation so I can solve for the number. So I'm going to write what they said, which is 30 over 100, 30% times a number, I don't know the number, is equal to 45. You understand that part so far? Understand that? You have to answer, you know.
Yes, sir.
All right. So I'm trying to find the n first. I'm trying to find the n first. So to find the n, I can cancel this down. So because I have zeros here, I can cancel the zeros. Like I divide the numerator by 10 and the denominator by 10. Divide this by 10 and divide this by 10. All right. So let me go a little bit slower now. I'm going to multiply this 10 across this side, and I'm going to divide this 3 under here. All right. So the n is going to become 445 times 10 over 3. Understand that?
Yes, sir.
Good. And then what I want is 4/5. So I can, in the same breath, just multiply both sides by 4/5 because I want 4/5 of the number. So I can multiply both sides by 4/5. Multiply by here so by 4/5. I multiply this side also by 4/5. And I will work out what this is, don't have my answer. If I work out that, I will have my answer. Just cancel out what I need to cancel out and stuff, and I'll have my answer. Now what is now? This 3 times 5 right there says 15. Can you see that? And 15 goes into 45 3 times. 3 times 5 is 15. So the 3 and the 5 is 15. Cancel into 45 3 times. So all I'm left with now are these numbers to multiply. 3 times 10 times 4. The 3 times 4 is 12 now. Only number here so over 12 and 9 is this. So this must be the answer. This must be the answer. It's equal to 120. 3 times 10 is 30 times 4 is 120. So the answer is 120 right here. So this guy just working towards what they said. 30% of a number is 45. Ideally, you want to find the number. And then after you find the number, you calculate 4/5 of the number. Multiply the number by 4/5. Because we're in the exam, I don't have to show no work. We just want to get it the quickest way possible. But the first line is to be able to write this based on this information that they gave us. This caused me to write that. 30% of a number is 45. Then I proceed to try to find the number. Right? Proceed cross multiply and stuff to find the number. Then after I find the number, I multiply it by 4 or 5. Simple as that. All right. This next question. Again, we can count the decimal places moved for this one. All right. So this number and this number is the same. They don't change. That number didn't change. The only number that changed was this one. The decimal point moved 1 place to the right. So the only move that took place was the decimal point moved 1 place to the right. 1 place to the right. So the answer is going to move 1 place to the right. To here. 1 place to the right. That's all that will happen. 1 place to the right is the only movement. So the answer for this, no, for this one, this becomes 15.91. 15.91. So the answer is this. This question easy, let's move the decimal point. But the values are basically the same values, just where the decimal point is. This and this is the same. So the whole movement was that this decimal point moved one place to the right to get to this. And so all I need to do is in the answer from this side, I'm moving one place to the right as well. So that's what I get that. Move one place to the right. That's it. So it's 15.91. Not gonna do it anyway. That's the easy way to do it. So another question here, almost the same thing. Same values again. See it? Same values again. So again, we're gonna count the decimal place. So the decimal place is moved. So this one compared to this one. Decimal point move one place to the left. All right. So decimal point move one place to the left. That's a -1 movement. That's to get to this. And then to go from this one to this one, move the decimal point 3 places to the right. So this to get a 0 out here and become this. Move the decimal point 3 places to the right. 1, 2, 3. That's a +3. So the net movement is +2. 2 to the right, 3 to the right, and 1 back. So the net movement is a +2. So this decimal point will move 2 places to the right. 1, 2 to here. And the answer for this, therefore, is gonna be with decimal point right there. So after the 9, which is 159.1. That is the answer. This right here. But you can also know that the answer is like that, you know. Look what I could know. That number here is so close to half, you know, 0.4. So it's almost like me I take half of 370. Half of 150 something, you know. So this could be the answer, this could be the answer, and this could be the answer. Right? Because if I use an approximation method, I could just treat this like as a half. But what it is, you know, all these digits are the same. Right? It's just that this is a ones number, that's a tens number, that's a hundreds number, and that's a thousands number. What kind of number we're gonna get from this? This is about half, 0.5. Times this is almost 0.5 times 370. So the number is gonna be like around half of 370, which is about 150 something. Somewhere near there, so 100 and something. But half of 370 is about 190 something or whatever. But no matter, you're gonna get 100 and something. So it has to be the answer that is 100 and something, and not the answer that is in the hundreds, which is this one. It has to be that one is the answer. So it didn't have to actually work it out. A lot of these questions, you cannot use simple reasoning like that, you know. Right? The size of the number, but the answer must be the size of this must be something in the hundreds. Because this is like point something, right? 0.5, almost near 0.5 times this. So you just take half of that almost. Must be in the hundreds. Half of this must be 100 and something. So it has to be a number in the hundreds. So this is the only one in the hundreds, so that had to be the answer. But again, I could just call the decimal points more. All right, that is it. Next one, that's another ratio question. A total of 540 beads are shared in a ratio of 4 to 5. The larger share is what? Now look how we can get the answer here quick now. You see a ratio of 4 to 5 here, so? It's almost half and half, you know. Almost half and half. 4 to 5. Almost half and half, you know. So the larger share is just a little bit more than half of this. If you look at these numbers, this is less than half of that. That is a 540. Half of 540 is 270, you know. 270, yeah. So this is already less. So it could not be the answer, but you want the larger share. The larger share must be more than half. And 270 is half. So it can't be this. It can't be 60. Can't be 270. No, it can't be this either, because that's far from half of 540. So you could actually eliminate the answers. It cannot be this. It cannot be this one, because this one is more than half. And the 5 portion is more than half of the share. So it can't be 240 either. Then it cannot be this one, because this one too close or too far from halfway. the 420, 430 something. This is too far from halfway of 270. So this could be the answer. You want a value that is a little bit more than half. The number that is a little bit more than half is a 300 right there, so in the answer. So it had to be the 300 is the answer without actually working it out. That's how we can reason out some of these questions because this ratio of 4 to 5 is almost half and half. Just at this part, a little bit more than half. And this is a little bit less than half. That's what it is enough. But if you want to work it out, then you could say, okay, total parts is 9. Total parts is 9 parts. And this portion is 5 out of the 9 parts. Right? You could say it that way. Hold on a second. Right? So, okay. So, setting up now the larger portion, we're working up by calculation. The larger portion is 5 out of the 9 parts. The total parts is 9. And the total of 540. Right? So you're basically doing the 54 divided by 9. That's what you're really doing, you know. Right? So you know a times table, 54 divided by 9 is 6. So if you cancel it down, then 9 into this 1 time, 9 into this 6 times. So it becomes 60 out of this 0. And then the 5 times 60 is 300. This is equal to 300. So you see, it can be done, could have been done by just reasoning out the numbers. Remember now, guys, the answers are there on the paper, you know. So you can look at them and eliminate them, see which one it is, you know, based on the values. The answers are there on the paper. So not everything you have to work out fully. Some answers just impossible, just cannot be there. In this case, these 3 cannot be there. Cannot be any of those 3. Never be. All right? But anyway, let's continue. I think most persons just want to be able to calculate and stuff, right? So let's go. But I'm still going to show you the reason behind it because mathematics, a lot of reason can be put in it. The first 3 common multiples, of 3, 4, and 12. And the answers are there, guys.
D.
What you say? D?
D.
Somebody say B?
Yeah, D. D as in dog.
Oh, all right. I don't want you to call it answers though, yeah?
Yes, sir.
Everybody else call it answers, we'll never finish. The answer is D. We could use a process of elimination. It can't be these because it said multiples. Multiples must be greater than factorial. Right? And it says common multiple. So if it's a common multiple, 6 is not a multiple of 4. 6 is not a multiple of 4, so it could not be those. So you can eliminate. And then here, 9, that 8 is not a multiple of 3. It has to be that D. Mute the mic, please. Mute the mic. The answer is D. It could not be any of these. So this is like an elimination method. Mute your mic, please. All right. This question now. It says, Dan sold 40 tickets, concert tickets in 5 days. Each day, he sold 3 tickets more than the previous day. It's only 5 days and 5 days. Now, this we could use a method that we call arithmetic progression in ADMAS, but then this is not ADMAS, right? Each day sold 3 tickets more than the previous day. The number of tickets sold on the 3rd day, so I don't want the number of tickets sold on the 3rd day. So look at what I approach a question like this. I don't know how many tickets sold on the 1st day. I call the 1st day number X. I'm gonna line it up like this first. That's only 5. So it's 1, 2, 3, 4, 5. I'm just gonna list them out. Pick. So I'm gonna say, all right, the number of tickets sold on the 1st day is X. The number of tickets sold on the 2nd day is X plus 3. I keep selling 3 more. The number of tickets sold on the 3rd day is X plus 6, 3 more. The number of tickets sold on the 4th day is X plus 9. The number of tickets sold on the 5th day is X plus 12. And I add up these, and they must equal to 40. And then I'm trying to find the one, the X plus 6. So this is 5X, right? 5X that. 5x, so I have 5x here, plus, then I'm adding up these. What I'll add up to? So this is 9 and 9, 18, 18 and 12 is 30. That's correct? 9 and 9, 18. 18 and 12 is 30. So that's my equation right now. That's my equation. Let me make this a little smaller. And I'm basically trying to find x first. So you can say that x is going to be 2. But if I subtract the 30, I'm going to get 5x equals 10 and then divide by 2. Let me continue up here. So I'm going to continue up here. So I'm going to get 5x equals 10 and then x equals 2. So this is the number sold on the 30. So all right, 30. 30. Was x plus 6 is 2 plus 6 is equal to 8. So the total sold on the 30 is 8. Well, this is not good enough way to do this question. As well as the 5 values, you can just list it out and add them up like that. But good? But okay?
Yes, sir.
Yes, sir.
Don't want the number sold on the first day to be 2. So I might take the question again and ask for the number sold on the 4th day, or on the 2nd day, you know, or on the last day. You can ask anything. You can say about the same values and ask you stuff like that.
Sir, I told the answer. X equal to?
No, see me circle the answer there, sir. The one the number sold on the 3rd day.
Oh,
2 is the number sold on the 1st day. But this is the 3rd day. That's what they want to, the 3rd day.
okay.
They wanted the number sold on the 3rd day. And that's why I put that as the answer, 3rd day. All right? That's what they wanted, the 3rd day. 3rd day, which is the x plus 6. So the x is 2, but the 3rd day you add 6 to it. That is it. This question now, these two questions are the same really. The square root of 181 lies between, square root of 191 lies between. So you need to know your perfect squares up to 15, guys. You need to know your perfect squares up to 15. Now 13 squared is 169. See there, 13 squared is 169. And 14 squared is 196. Eh? 181 falls in between those two numbers. And the square root of this you want to know. So your answer, the answer is like you're doing a reverse of you're doing a reversal. So since you want the square root of 181, you want to know what the squares of these values are. So your answer for the square root of 181, because 181 falls in between here. 181 falls in between here. 181 is between those values. So the square root of 181 must be between these two values. And so the answer is this one. And it's the same for this question down here, so same exactly. We'll copy this and paste it right here. Same solution. Right? This time I want 191. 191 is also between them. So the answer is still between 13 and 14. That is it. Good, because 13 squared is 169. The next perfect square is 14 squared, which is 196. 191 falls between them. So the square root of 191 must be between 13 and 14. All right? That is it. Our next question. Over here. Oh, there's none on this. So I finished that part. So we're going into consumer arithmetic now, guys. No, we're going into functions. Functions. No, sets. We're going into sets. Sets. So let's basically finish the first part. How long are we going? Want to take a 5 minutes break? Now we're going to sets. Want to take a 5 minutes break,
Yes,
and then we're going to sets? All right.
Yes, sir.
Let's take a 5 minutes break.
Yes, sir.
That's it. All right. I want you to pay attention good today, so I don't want to go too lengthy in a segment. So just a 5 minutes break, screen break, I call it, and then we shall pick up back. Remember, the video is gonna be here online, guys, so you can go back and look back at it. You have 2 days. Depending on how far we reach today, we might have another session tomorrow. I think we will have another session tomorrow. If we finish this document, then we maybe can just do a paper, full paper, an actual paper. All right, and let's work through an actual paper. And we see nobody's questions repeated. So that is what we shall do.
Oh, I'm so sorry to repeat. So, I'm done. Let's see. Ah, let's see.
All right, guys, we're back. All right, so going into sets now, right? Now, think about sets. That sets pose a kind of challenge to a lot of students in recent times because it is not taught after third form, and also because it's not on the paper too. We don't get a lot of exposure to sets questions because it's only on paper one. So if you don't get some paper ones, in recent time paper ones, right? You're not gonna get any sets. Right? If you're gonna do sets on past papers, it's gonna be on the long time paper twos, old time paper twos. All right, so that is a challenge with sets. I find that a lot of students have a challenge with sets. So let us try if we can clear them up today, or at least be able to do these exam level questions. All right. So this first question here, right here. Which of the following statements describe the set of integers? Integers are positive or negative whole numbers, represented as C, integers, greater than -3, but less than 6. So this is called between -3 and 6. You can look at it that way. So how you set it up is that the x is between -3 and 6. Because if you're greater than -6, -3, but less than 6, then you're looking for values between -3 and 6. So you're gonna put x in the middle. Now x in the middle is gonna be greater than the smaller value over here. And then x in the middle is gonna be less than the larger value over here. So you must always list out the values, smaller one on the left, larger one on the right, and you put x in the middle. So you must end up with 2 less than signs. But here, we are saying the x is greater than -3. And here we are saying at the same time, the x is less than the 6. Less than the 6. So that is how it will appear. So the answer that looks like this is the answer, which is right here, the last one. And the Z, the number symbol, the number theory symbol for integers. This thing means is a member of. So X is a member of integers. That is a symbol for a member of. So ZR is a symbol for integers. And this one, I don't remember its name, is a symbol for is a member of. So it's saying that these are your X values and they are X is a member of the set of integers. So X is an integer. All right, Z is for integers. Another question, similar. Which of the following set describes this? Saying the same thing again. The Z are integers. So X is a member of integers. Integers are positive or negative whole numbers. Positive or negative whole numbers. All right. And this now means that you're now including, because of the equal here, you're now including the -2. And the equal here again means that you're including the 4. So you want all the whole numbers, positive or negative, that starts at -2 and goes up to 4. If I were to show this on a number line, right, then on a number line, it would appear as this: 0, -1, -2, 1, 2, 3, 4. And I'm including -2, so I will put a shaded circle on the -2. And I'm including the 4, so I put a shaded circle on the 4. And then I would want the values in between here. But because we want the integers, we're only going for the specific whole number values, these. We don't want the intermediate values. We don't want the values between them. We only want the actual values because we only want the integer values, which are the whole numbers. Z are integers. And integers are positive or negative whole numbers, including 0. 0 is a whole number. So we're talking about these, the last one. you're including the -2 and including the 4 because of the equal sign and the inequality. Right? If I would give you, just give you like a quick recap, I don't know if we can write it here. Let's give you a quick recap on a different page. Less of the number system, just because I know a lot of persons maybe have not done sets, right? Let's give a quick recap of the number. The main number system that you should be familiar with, the symbols. So n are what we call your natural numbers. Right? N are your natural numbers. Numbers that you count naturally. N. Natural numbers. It starts at 1. It's also called your counting numbers because they start counting from 1, right? Counting numbers. So what we'd like to say is that the numbers that you count naturally. You tell a baby to count, they're gonna start counting from 1. So counting naturally start from 1. So it would be like 1, 2, 3, 4, 5, and so on. Natural numbers. Then you have W is a symbol for your whole numbers. So whole numbers really is used to measure whole. Right? Remember, 0 is a whole number. 0 means none. So whole numbers are your natural numbers and 0. So when you add 0 to your natural numbers, 0, 1, 2, 3, 4, 5, and so on. You have now formed a set of whole numbers. All the difference that you add in the 0, your whole numbers. Then you have Z. Z are your integers, positive or negative whole numbers. Your integers. That's the symbol for Z. Z are your positive and negative whole numbers. So I know for whole numbers. So the integers can go like this. Like we start from infinity and we reach -4, then -3, then -2, then -1, then 0. And we're going to the positives now. 1, 2, 3, 4, and that continues on as well. So these now would be your integers. So we go further back on the negative side, go further forward on the positive side. And it includes 0. Those are your integers. All right. They have a symbol for this one. This one is a member of, one that looks like an E. In set notation is a member of. Is, so if I write A and put this in between them and then write the B, I'm saying A is a member of. A is a member, out like this. A is a member of B. It's like A is one of the elements in set B. And usually A is a member of B. So it's usually referred to an element, one of the values. So like X. I'm gonna write XA, right? Just make it with B. So I'm gonna changes to X. So X is like one of the values, like one of the values in set B. So if we draw a set, and this is set B, might have values in there like X and Y and Z. And X is one of those values in B. The member of. They have a symbol. This one is a subset of, that's a subset symbol. So usually refers to sets, like A is a subset of B. This one is saying set A is a subset of B. Talking about sets now. So it's like you have a set like this. And within here, you might have two sets. And let me put this as a universal, the universal set U out here. And let me draw a box in here for set B. This is set B. And then X is a member of set B. Inside here now, I'm going to put a set B. Inside set B, I'm going to put set A. And the universal set out here. So this would mean that. It means that A is inside of B. A is a subset of B. This is a symbol for subset. The symbol can be reversed this way as well. So if it reverse that way, I can put the A over here and the B over here. So it means that A is still a subset of B. Read it that way. And then B contains A. But usually this is a symbol that we see. So let me not put the reverse ones. Because I don't really put the reverse ones most time. So it's this and this you will see. So those are your set notations so far. All right. As we do more of the questions, I'll explain some stuff. Because spend some time on this one, because as I said, I know we don't really get a chance to touch back sets after third form in most cases. All right, they'll just pop up on us on the multiple choice papers. All right, let's continue. All right, so this question now is a kind of popular question that we like to say, where they give you a set, finite sets, and they tell you the number of elements in P, number of elements in Q, the number in the unit. So I'm going to give you a general formula for this set notation, like a set, it's like a set formula for finite sets, right? Especially when you have two sets. I'm going to give you a formula that you can just you can remember it and use it. It's valid for any two finite sets. For any two finite sets. And let me set it up so that you can understand it if you don't before. So let's say I have a set A and I have a set B. And there's an intersection there, right? So there are some values in between here. There's an intersection. All right. Now, when I say the number in set A, I'm talking about everything included in the intersection. That's what I mean by the number in set A, the number of elements in set A. When I say the number of elements in set B, I'm talking about everything in set B, everything in set B. When I say the number in the intersection, like the number in A intersect B, this is talking about right here alone, the intersection. That's what that is talking about, the intersection. And when I say the number in A union B, I'm talking about everything in here combined. Everything in here combined. All right? So how do we connect these four things in a formula, make a relationship? Look at it now. Look at it now. The number in A plus the number in B. I want to make this a little smaller, you know, so that I'll make this a little smaller. I'm writing too large on the screen, and then I want to have space. So I'm gonna zoom it up now. All right, let's do it this way. Even smaller still. All right. Good. So when I want the number in A plus the number in B, right here, it's like I'm adding a number in A. Let's put the number in A in red. Like I'm putting a number in A, which is all of this, right? That's what that would be. Let me put this in red, so that it becomes clear. Let me change that to red. No, it didn't change. And then now I'm going to do the number in B in black. So I'm doing the number in B now in black. So it's everything in B in black. So I get the number in B in black. So it's almost like I'm trying to get the union. I'm I'm trying to get the union, you know. So if I can adjust this formula and say, okay, let's start trying to get the union. Okay, looks like the union right now, you know, that I did before. When I did the union, I shaded everything, right? When I did the union, I shaded everything in A and B. So let me set up for the union. So let me set the number in the union. The number in A union B will start out being the number in A plus the number in B. But if you look closely, the intersection right here is really added twice. It is added when I do the number in A and added again when I do the number in B. So for it to become form, for it to become true, I cannot add the intersection twice. It means that I have to subtract it one time. So in this equation here that we have now, I will have to subtract the intersection. So I have to subtract, put it in green. The number in the intersection, but it was added twice. When I added the A and the B, the intersection was added twice. Right? And when I have the union, I cannot add the intersection twice. So I have to subtract the intersection, which is A intersect B. I have to subtract it one time. That becomes your set formula, you know. And then what happens now? I can transpose this intersection over this side and add it up to this side. And so I come up with one formula that I want everybody to remember now. The number in the union plus the number in the intersection. That's when I transpose this over here and add it. Will always be equal to the number in A plus the number in B. This is the formula everybody must know. What I just did a while ago is give you an explanation for it. And the same formula works also for probability. For those who are going to do probability at a later stage. Works also for probability. The probability is just how many in a set out of the universal set. So when they give you these questions, this is what you're trying to look at. The total of the union and the intersection must always be equal to the total of the individual sets. Simple as that. So if I look at this one now, this question over here now, right? This question can be solved very, very easily using that. The sum of these two must equal the sum of this one, this is the union, you know, and the intersection, this plus the intersection, number in P intersect Q. So if these two add up to 14 and this is just 10, then the one here must be 4. Because 10 and 4 is 14. And these two adding up to 14. So I need 4 to go with the 10. So it means that the intersection must be 4. Must have 4 in it. Simple as that. Simple as that. So the answer is 4. But understand that? Can I ask you for the intersection? Intersection must be 4. Students, understand that?
Yes, sir.
Yes, sir.
As simple as that.
Yes,
The
sir.
sum of the P number in P plus the number in Q must always be equal to the number in the union plus the number in the intersection. So I have to look what these two add up to. Those two add up to 14. This is 10, so you need 4 to go with that. What is missing? The intersection is missing. So the intersection must be 4, which is what they asked us for. So they asked us for it here. This is the number of elements in the shaded region. The shaded region is the intersection. The number in P intersect Q. The shaded region is the intersection. Has to be 4. Right? So you can say 5 plus 9. I'm gonna write it this way. P plus Q must be equal to P union Q plus P intersect Q. I'll just leave off the N. So this is 5 plus 9. 5 plus 9 must be equal to 10 plus, and this has to be 4. This has to be 4. Put it in the right. I never know before. That is the answer. The answer is 4. Where is 14 must equal 14. That's what we say. 14 must equal 14. And anytime you see a question like that, you don't more set. Just remember this. Just remember this that I just showed over here. Alright? Sum of the individual sets must equal the sum of the union and the intersection. Alright. So we've done that now. So anyone miss like that, I'm just do it then. I'm just gonna do it. Okay, let's go. I'm gonna pick up these markings. Let me leave them. Let me leave them because they're important. So I'm saying these two add to 14. So this need a plus 4 to become 14 as well. Alright, that need a plus 4 to become 14. That's why the plus 4 is what is missing, which is the intersection. Alright, so I want to see similar question like that. Let's go. This question now. Alright, pay attention. So this, oh, I forgot about this symbol. That symbol is the intersection symbol. And you know that is the union symbol, right? So intersection is what is it to all of them. So here now, this question is asking us for the intersection of these 3 sets. What value is common to all 3 sets? That's what the intersection is. What value is common to all 3 sets? P, Q, and S. The only number common to all 3 sets right now is a 2. 2 and a 2.
Number 2.
Good. The value 2. So the answer is A, right? Answer is A. All right. So likewise, it's a bad now. Answer that one up now. This one. So this one says P. Let me write it so that it is clear. This one is P intersect bracket Q union S bracket equals. That's what that one say. I'm sure you can see it good. What is the answer for this one? What do we get this one? No, plenty of people will know this question. You know? And also the answer is 2 now, from seeing it a number of times. And then see this one, I run our answer 2. That's wrong. Tell you right up. It's wrong. Why it's wrong? Because this and this is not the same thing. So who could tell me what the answer for this one is? First, who does tell me that this one is 2? Tell me what the answer for this one is. Can you tell me? Give me a chance. I'm spending time on this one because it's a topic not set a lot of time. Spend a little bit of time on it. A topic not
Sir, C, 2, 3, and 5.
2, 3, and 5. All right. I think you are correct. Well, let's work it out. So to do this one, what I would do, I would put back the P set, work out what the Q union S is, and then look for the intersection. All right? So I write by the P, I'm going to work out what this is. I'm going to write by the P set. And the P set is the 2, 3, 5, and the 7. I think you're correct, Emma. I think you're correct. And I'm going to write by the Q union S now. So the Q union S, not U, Q union S. It's basically everything in S and Q. Remember, you can't repeat any of the values, right? Each element can appear only once. If you draw a Venn diagram, they will just be in the intersection. So all the values that are in Q and S, so Q and S right here, so without any repeat. So the 2 is in there, 3 is in there, 4 is in there, 5 is in there, 6 is in there, in the union, not the intersection, not the union. So by the way that this is Q union S. Then now from these two, you're looking for the intersection. That's what that is now. You know. This is the intersection of P and the Q union S. You're looking for the intersection of these two now. So if I underline the intersection, these two, the intersecting values, 2 would be in the intersection, 3 would be in the intersection, 5 would be in the intersection. Those 3 values. That is why, yes, she's correct. This is the answer, 2, 3, and 5. will be in the intersection of those two. Correct. Beautiful. But understand that before we move on. So don't do this, you know, guys. I'm gonna put 2 in now. Make sure,
Yes,
pay
sir.
attention. All right, make sure. Them set that one and set one like that. Be careful. Don't go and put on the 2 because you're familiar with this one. Because this one set a lot of papers. You know? Right? So those who are fortunate to see a lot of papers will see this one a lot. Right? This one don't set very often. So look out for it. All right. Let's continue. See this one now? This one is the exact same as this one over here. Exact same thing. It's the exact same question. Just for this one to show the shaded region, and it's a shaded region down here. And then this one now say ask for the intersection, which still is a shaded region, a region in between there. So the answer is the same. See, these two again add to 9. This is 5 and this is 9. You can see it. Zoom it up. This is a 5. That's a 5. And that's a 9. It's the same question here. And these two add to 14 again. These two add to 14. So this and this must add to 14. These two must also add to 14. So for them to add to 14, this one has to be 4. But this is already 10. This has to be 4. Simple as that. All right, we're going to keep it that way. So the answer right here is 4. Simple as that. We don't have to complicate it. All right, we don't have to complicate it. Let me write it down. Number in P plus the number in Q must be the number in the union. Shift it over a bit. Plus the number in the intersection. Right? So since we have this one is 5, this one is 9, this one is 10, and this one over here has to be 4. Has to be 4. So the same question. But this side is 14. This side also must be 14. They must equal the same. All right, beautiful. Let's continue. So I'm not sure everybody get that. This question. This question says, it refers to these sets. These are your prime numbers. These are odd numbers. These are even numbers. Which of the following set is empty? Which of the following set is empty? Empty means null. Another word for empty is null. A null set. Nothing is in it. So which of them is empty? Could it be this one? Is there any value that is prime and even at the same time? That's what this one is saying. Intersection, prime and even. Huh?
I said 2.
2, good, very good. So 2 is the only even number that is also prime. 2 is the only even number that is also a prime number. 2. Remember, 1 is not a prime number. Plenty of people have the misconception that 1 is a prime number. 1 is not a prime number. The first prime number is 2, and it is the only even one. Every other prime number is odd. All right? So that is not empty. This would have 2 in it. Right? So this would have a 2 in it. So it is not empty. This would have a 2 in it. I'm going to zoom it up and write it. So it is not empty. And this one now, Q intersect R. That's these two. Plenty, only. So this one, for example, would have 3, 5, 7, 11, right? Other than, no, which two we're doing? Q and R. Oh, that is the empty one. Wow. This is the empty one. There is no odd number that is also even. So this one is the empty one. This one is the empty one. So this one is the answer, right? Q and R. P and Q. P and Q are lots. P and Q a lot. Right? A lot of numbers that are prime and odd. In fact, the majority of them. In fact, all of them except 2. So it will be 3, 5. I'm not writing good. 3, 5, 7, 11, and so on, right? Plenty of them. Then this is union now. Odd and even. So that would include the 2 now. So this would include the 2. So it would include the 2 because union. The 2, the 3, the 5, the 7, odd and prime. And you have to put back the 9 and so on, right? Because you want the odd and prime. So it's 2, 5, 7, 9, 1, 2. You have to put in 1. 1 is an odd number. Union you do, so you have to put in 1 as well. 1 is an odd number, so you have to start at 1 actually. Right? So it's all the odd numbers and then this 1 even number in there. Because that is the only even number that is prime. And you go on and on forever. So this is a null set. So that is the answer. There's no odd number that is also even. That was an easy question. Let's continue. This next one says A is this set and B is that set. Which of the following statement is true? Which of these is true? If I look, I see 6 here and 6 here, 9 here and 9 here, 12 here and 12 here. So it means that all of B is inside of A. That means that B is a subset of A. This means a subset of A. So the correct answer is the first one right here. Because all of B is inside of A. So this is the answer. This is saying the intersection. This means null set. That's a symbol for null set. Another way of writing, this is a symbol for null set, which also can be written like this. So these two mean the same thing. Disjoint set. What are disjoint sets? Disjoint sets are like mutually exclusive events, like 2 sets that don't intersect at all. Just like the odd and the even sets. Disjoint. Right? And then complement. Complement means everything that is not in a set. That's a complement. B is a complement of A. B is a complement of A. No, it's not a complement of A because it actually has them in it. This is the answer though. That is the answer. B is a subset of A. That is the answer. All right, next question. If a universal set is this and H is this, then what is the complement? This is not a complement. This symbol means complement. Means everything that is not in H. So what we can do is mod the H. This is a H value. That's a H value, and that's a H value. So everything else falls in the complement. These fall in the complement. These. So I'm going to put them in red. 1, 2, and 5 will fall in the complement. So we're looking for 1, 2, 5. See there? Everything that is not in H, I'm underlining these in blue. I'm saying that these were the values in H. So H complement are the values that are in the universal set, but are not in H. That is it. Easy question. This one here, let me brighten this up for you. So you can see what it is saying. Brighten it up in purple. So this is a 6. I'll brighten up in red. This is a 6. It's a less than or equal to, this is X. This is less than 10. That's what that is right over here. So 6 less than or equal to X less than 10. And it's where X are integers. X are integers. That's what the question is. I was rewriting the question for you. That's not so clear. Which one this is it? So it says greater than or equal to 6. So it means that they're going to include the 6. And since that integers, they only want the whole number of values. Integers are whole numbers, positive and negative whole numbers. So the next one is 7, then 8, then 9. We cannot include the 10 because there's no equal on the inequality here. So you cannot include the 10. So that is what this is. So this is basically that. All right, so that's what I'm looking for, which is B. So the answer is B right here. That is it. All right, nice and easy. Nice and easy. Next question. This question now says, you give us these two sets as PQR, and that is PQ. Again, you can see that everything in P is inside this. So you could say N is a subset of M. But also, if we were to draw these two on a Venn diagram, then all of N would be inside of M. If we draw it on a Venn diagram, which of these is correct? This is saying M is a subset of N. That is not true. This is not true. It is the other way around. N is a subset of N. So the truth, what is true is that N is a subset of M. This is what is true. This is not true. So don't go and write this in. That's not true. You have to read it from left to right. M is a subset of N. That is not true. It's the other way around. N is a subset of N. And this one now says the intersection between M and N is also equal to N. This one is true. Because the intersection would be P and Q, which happens also to be set N. That's what it is. So the intersection, see there, M intersect N is actually equal to P and Q. And the N is also P and Q. And that's why this statement is the correct statement. That is true. Is this true? The union, no. The union will include R. And N don't have R in it. So this is not correct. And then this one is saying the intersection is a null set. No. The intersection, I just showed it here a while ago. So this also is not correct. So the answer is B. The answer is B. This is what is true about the subset, this one right here. All right, that is what is true. All right, over what to go to that. But okay with that? Just trying to spend some time on this for the purpose of those who.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Beautiful.
Yes, sir.
Which are the following are examples of disjoint sets? As I said a while ago, disjoint sets, I'm going to draw it again, are two sets with no intersection. Two separate sets. If you draw a Venn diagram, they will be separate. There's no common value, no value common to them. These are disjoint sets. We say that they are mutually exclusive. So this says a set of even numbers and odd numbers. That is it enough. There is no even number that is also odd. So the answer is this enough. Even numbers and odd numbers. So this is the answer. They would form disjoint sets. Set of even numbers are by themselves. Set of odd numbers are by themselves. Okay, this is a multiples of 2 and multiples of 3. No, because multiples of 2, for example, is 6. So 6 would be in the intersection of the multiples of 2 and the multiples of 3. All right? So those would not be disjoint. Whole numbers and rational numbers. What are rational numbers? Rational numbers are numbers that can be written as a fraction with an integer whole number and an integer denominator. Integer numerator and an integer denominator. So for example, a whole number would be 2. So if, for example, I say, what about 2? 2 is a whole number now, but it can be written as a rational number because I can put it over 1. So basically, all whole numbers are rational numbers because all whole numbers can be written as a fraction like that. So as I turn the 2 into 2 over 1, a rational number is a number that can be written as a fraction with a whole number on the numerator and a whole number on the denominator. The only thing is that the number on the denominator cannot be 0 because if it is 0, then you don't have a real number. And a whole number, a rational number, has to be a real number. Right? That's what a rational number is. So let me write it out here for you. A rational number. A rational number. Just for just for information. A rational number is a number that can be written as A over B, where A is a whole number. Well, let's put an integer, but it's an integer. It can be positive or negative. And the B is also an integer that is not equal to 0. That's what a rational number is. A number can be written as a fraction, right? And therefore, all whole numbers are rational numbers, because all whole numbers can be written as a fraction. All you need to do is put it over 1. All right? Multiples of 5 and multiples of 10. Well, all right. So this would be in an intersection, because, for example, a number like 50 would be in the intersection. So those would not be in disjoint sets. All right. So let's put this here for information, guys, for the rational number. Because when we're doing the number theory, we didn't mention rational number. What are irrational numbers? So if these are rational numbers, then an irrational number is a number that cannot be written as a fraction with whole number, numerator, integer, numerator, and denominator. Irrational numbers are numbers, for example, like the square root of 2, square root of 3. Let me write out. Irrational numbers. Irrational. This is spelled with 2 R's. Or 1 R. I don't know. It doesn't matter. Irrational numbers. Right? Numbers that are not rational. Example of irrational: root 2, root 3. What's another irrational number? Pi. Pi is an irrational number. So even though we often say pi is 22 over 7, that is just an estimate. It's not the true pi. That's just an estimate. Pi is not actually equal to 22 over 7. It is just the best estimate of pi. But pi is an irrational number. All right? So 22 over 7 is just an estimate of pi. It's not the true pi. So these are examples of irrational numbers. They cannot be written as a fraction with a whole number, numerator and denominator in exact terms. Square root of 5, numbers like those are examples of irrational numbers. Cannot be written like this. It is irrational. All right. Rational comes from the word ratio, which basically is like a fraction, right? Okay, good. All right. This one says, all students in a class play Scrabble or checkers or both. All students play Scrabble or checkers or both. What's a question like this? I'm tempted to draw my Venn diagram. And the Venn diagram will give you a visual of the information. So I'm going to draw my Venn diagram. It will help. So I'm going to just draw a little Venn diagram right here. Put on a set for my Scrabble. Put on a set for my checkers. So Scrabble, checkers. Now this is talking about percentages. You can put percentages on your Venn diagram. What it means is that the universal set, will add up to 100% when you put it in percentage. So you can show the actual values on a Venn diagram. You can show the number of values on a Venn diagram. You can show the probability of getting a value on a Venn diagram. Or you can show percentage on a Venn diagram. You can show ratio on a Venn diagram. Right? Venn diagram can be used to show, can be shown in a variety of ways. You can show the actual values, actual members in a Venn diagram as well. This one is talking about percentage. So we're going to show the percentages. So what it says, if 36% of the students play Scrabble only, well, Scrabble only will be right inside here. Inside your Scrabble only. This is Scrabble and checkers. So Scrabble only is right here. So right inside, I'm going to put 36. 36 right here. If the question did said 36% play Scrabble, then I'll put the 36 up here, which means I'm including the intersection. But it said Scrabble only. So this is Scrabble only. 16% play both. So 16% is inside here. 16% is inside there. It says, what percentage play checkers but not Scrabble? Them say inside, it's inside there, they're asking for me, right here. This question is asking for here. Remember, I know it said all students play checkers or Scrabble or both. It means that there's no note here. So this is none. So what it therefore means that everything must add up to 100. So we need a figure that is missing to make 100. It means that inside here, so is how much? 52. Inside here, so add up to 52. So Scrabble is 52. So inside here, so add up to 52. And this is the only place that anything is missing. So inside here, so must be 48. 52, you need 48 inside here. So 48. Remember, you must add up to 100%, guys. So the answer is 48. But understand that? But understand that?
Yes, sir.
Yes, sir.
Yes, sir.
The important thing that everything must add up to 100 because it expresses as a percentage. You're writing up the Venn diagram as a percentage. The total percentage must be 100. All right, we have accounted for 52. We said that there was none out here based on the question. Some part is zero. There's none out here. As it says, all play Scrabble or checkers or both. So it means that there's none out here. So everything must add up to 100. So only 48 that is missing. That's the one that plays checkers only. Checkers but not Scrabble. All right, that is what it is, 48. Next question over here. All right. So this question gives us this diagram. That's a Venn diagram. So refer to the following Venn diagram shows two intersecting sets. The number of students in each set is indicated. So these are the number of students. Number of students. Right? It says in the Venn diagram, use students who play games. Students who play games. So I'm assuming that these play games as well. 8 are the students who play hockey. V are the students who play volleyball. Volleyball. So these out here play something else. This question is ambiguous. It says, how many students play either hockey or volleyball, but not both? This and this, you know. Hockey or volleyball, but not both. Mute your mic, please. Mute your mic, please. Mute your mic, please. All right, so this question is referring to the persons in here and here. So it's 5 plus 9 is the answer. This is 5 plus 4, sorry, is equal to 9. So the answer is right here, 9. Well, the same question was set on another document some other time, which was written like this. But I'm scrolling up here. It says the number of students in each set is indicated. How many students play exactly one game? The reason why I think maybe this question was rewritten to this one is that the original information said students who play games. So that include these out here. Right? And the way this question was written, you would have to include these out here. But that answer was not there. It would have to be 9 plus 3. All right? So that's why I think this question was written. But the answer is still 9. And that is assuming that these out here don't play any game, even though this originally said that is the universal set is for those who play game. And that's why the question was rewritten for this. It was rewritten that way. All right? So it's the same question, but they have the wording of it was updated. But this one is ambiguous. They use that wording. All right, let's continue. This one says the set of 2-digit positive integers that are divisible by 7 is an example of an improper set, an infinite set, an empty set, or a finite set. Now, what do I do? No, I don't know what this is. Improper set. The only thing I know about improper when it comes to set is improper subset. Somebody know about improper set, they can tell me. An improper subset, I'll do an example of the improper subset and show you just. But an infinite set is a set that does not terminate, goes on and on and on and on forever. So if we were to list the values of this, 2-digit positive integers that are divisible by 7. If a number is divisible by 7, it means it is a multiple of 7. A number that is divisible by 7 is a multiple of 7. This also means multiple of 7. multiple of 7. And no matter that is divisible by 7 is also a multiple of 7. We don't want the 2-digit one. So if we were to list them here, if we were to list them, then we would end up with numbers like 14, 21, 28, and so on. And we'll go on and on and on and on and on forever. That's what we refer to as an infinite set. What that one that goes on and on. No, I lie. Finite, you know. Finite. Because them said 2-digit. If it was just a multiple alone, we want it to be infinite. Because they said 2-digit. It's finite. What would be the last one? Go on and on and on. What's the largest number before we reach 100?
91.
91. So you go on and on and on until you reach 91. So it is a finite set. Finite. It terminates. It's finite. Came to a stop. It's a finite. There's a set number of values. So that's an example of a finite set. That's an example of a finite set. So this is it. Why? Because it simply said 2 digits. If it was only divisible by 7, then we go on and on and on forever. But the fact that they say 2-digit ones, the finite set. A finite set is one that terminates. Finite set. What's an example of an infinite set? An infinite set is one that does not terminate. Like for example, if you simply say multiples of 3 or just multiples of 7, it was just multiples of 7 or just multiples of 3. Like multiples of 7. Then that set you might want to write it as 7, 14, 21, and so on forever. That's infinite. An empty set, as we say, is one that don't have anything in it. Like for example, as we said, the set of values that are odd and even. So that's an empty set. Nothing in it. All right, I don't know what an improper set is. I don't know about that. And then the finite set now is one that terminates. So an infinite set is one that does not terminate. Go on and on and on forever. A finite set is one that terminates. All right. So this is an example of a finite set. This is an example of a finite set. That's what let's spoke about. All right. Very good. 91. So 91 as the last. And 98. I can't go nothing with the man. 98, man. 98 at the last value. 98. The last value actually. That is divisible by 7. 98, not 91. All right, last 2-digit number. That is divisible by 7. It's actually 98. All right, let's continue. Let's continue up here. This one. This one says, universal Venn diagram, universal set U, 2 sets T and C that represent the students in a class who play tennis and chess. So these are the tennis students, these are the chess students. Now clearly, all the students who play chess also play tennis, or they are a subset. So these two persons in here, for example, they play chess and tennis because they are inside the tennis set. So they play chess, you know, but they also play tennis because they are inside the tennis set. These now, they only play tennis, they don't play chess. And then these out here, they're not playing any tennis and they're not playing any chess. All right, that's what they're asking. Question says, how many students play both games? That's Paul and Rima. Play both games. So the answer is 2 persons. Paul and Rima in the middle. The answer is 2 persons. But go to that. How many students play exactly 1 game? These are the 4 out here that play exactly 1 game. 1 game alone they play tennis alone. There's nobody who play chess alone. No, C is for again. C is for chess, yeah. There's nobody who play chess alone. There's nobody who play chess only. So the persons who play one sport poorly, Ali, Alex, Kayla, and Tom. 4 of them play one sport alone. And one sport that they play happens to be tennis. They don't play chess. That is it. Nice and easy. But good? Okay with that?
Yes, sir.
Yes, sir.
All right. But I understand that Paul and Rima play 2 sports. They play both chess and tennis. But I understand that. Because they are, even though they are shown within the chess set, it happens that if the 2 that play chess also play tennis. They are also within the tennis set, so they must play tennis as well. All right, down here. This question here now says, it refers to a Venn diagram, number of members at a sport club who play rugby or basketball. The number of members who play rugby but not basketball is this. We're talking about 15. So then they play rugby but they don't play basketball. In other words, rugby. This means rugby only. Rugby
B.
only. 15 of them. That's what it means. The answer is B, yes, 15 persons. They rugby only. All right, let's continue. This question now. This question says, if the number of, this N out here, means the number of elements or the number of members. The number of members of set A is M. So M is the number of values. So M are maybe like 3 or 4 or 5 or 10, whatever. The number of values in set A, the number of members of set A is M. Is M. Then the number of subsets of A can be expressed as, this is it, 2 to the M. The number of subsets of a set is 2 to the number of sets, 2 to the number of values in the set, 2 to the N, if you remember this. All right, there's another example with that value I'm going to show you the details of it just now. And we're going to bring in the word improper at that stage. So the number of subsets of a set of n values is 2 to the n, 2 to the number of values, all right, in the subset, in the set. That's the number of subsets. There's another one right here now. So it's one here, same kind of question. So in this example now, they actually show you the set. The set is A, B, C. It says how many subsets can be obtained from it?
D.
Because the number, which one? D, right? Because the number of n values in it is 3, it means that the number of subsets is 2 to the n. So we're gonna say the n in this set is equal to 3. The number of subsets is 2 to the 3, 2 to the third power. Number of subsets is 2 to the n, which is 2q. So the answer is this. Now, what if we were to list the subsets? Just to write them out. Just to illustrate something. I'm just doing it to illustrate something. And let me write them out. All right, so I'm going to write out the subsets. So the subsets, firstly, we can have the subsets with one element on. So subsets, for example, the A, set B, set with B, and the set with C. One value. Then we can have a subset with 2 values, 2 elements. So for example, AB, AC, BC. So that's only 6 subsets so far. So we're going to get the other 2 subsets from. So we're saying 2 to the 6, 2 to the third power is 8 now. This equals 8 now. So there are 8 subsets. We're going to get the next 2 from.
A null set. Empty
Null
set.
The empty set.
And the original set.
And the full set. Beautiful. Beautiful. In terms of the word proper and improper, these 2 are what we call proper subsets. Proper subset, those 6. And these 2 that a lot of people tend to forget, especially this one, the null set is a subset of every set, and the full set is a subset of the set as well. These are what we call the improper subsets. That's where the word improper comes from, to my knowledge. When it comes to sets, that's where the word improper comes from. We're referring to subsets, the improper subsets. So when it comes to set, study of sets, that's where the word improper comes from. For me, I don't know if it exists anywhere, but from my time till now, that's where the word improper comes from. When you're referring to sets, improper subsets. This is 8. So that's how we get the 8, guys. Remember, the null set is a subset of every set, and the full set is also a subset. People tend to remember these, can write out these, and tend to forget these 2. The null set and the set itself. All right, beautiful. Let's continue. The set of positive integers is an example of a set of positive integers. That would be an infinite set, based on what we just described. Positive integers, because these now would be, for example, positive integers would be like, you can't include 0. 0 is neither positive nor negative. 1, 2, 3, 4, and on and on and on forever. It's infinite. Infinite. Go on and on and on until you reach infinity and beyond.
Sure. So if it was a negative integer, it would be an finite set?
No, it will be infinite too. I can have an infinite negative integer, like -1, -2, -3, -4, all the way down to negative infinity, just the same. Good question. I like that question. So them change this word to negative, still infinite. Understand? So these will be the negative ones. If they change the word, so let me put that into thing. So this would still be infinite if it was negative. I like that question a lot. All right, so like we're going that way. So mute the mic back. Mute back the mic, please. These are the positive ones. Mute your mic, please. Mute your mic, please. Mute your mic, please. After you open your mic and speak, please mute it back. These will be a negative. Still infinite. This is still an infinite set. This one is still infinite. So this one is infinite. And this one is infinite as well. Hello? Yes, quickly. Oh, all right, cool. Somebody pay attention. All right, cool. Thanks. All right. So guys, remember, if the question put this instead of, if they put negative in the exam, still infinite, right? They put negative. It's still infinite. All right. That is. Here's another question we're going to add up the values. So here now, remember, the rule don't include the universal set, right? Your focus is on these. The number in A plus the number in B right now. Those two add up to 29. So the number in the union, at the intersection, sorry, plus the number in the intersection in the union, sorry, this is the intersection, so we want the union now. Those two must also be 29. So this is a 6. You need 23. This is 6. Since this is 6, you need 23 more. So all right, 6 plus 23 is what is equal to 29. So the answer is 23 right here. So this is the answer. 23 and the union has to be 23. All right? Simple as that. Don't complicate it. Same thing here again. P and Q are two finite sets. Again, let's go back for the blue. And they give us the number in the union and the number in the intersection. So see, they give us these two this time. Those two add up to 19. So it means that these two must add up to 19. The number in P and the number in Q. These two must also equal 19. So since this is 9, then this has to be 10. So this is the answer. 10. The number in Q must be 10. So the answer is 10. So you see now that this question is really very easy, not complicated. And the number in the union and the intersection must add up to the number in the P and the number in the Q added together. All right, simple as that. These two must add up to. These two must add up to. Must add up to 90. Must add up to 90. All right, put a box around these two now. These two add up to 19. So these two must also add up to 19. So one of them is 9, the other one must be 10. Simple as that. All right, enough for that type of question. So another one, and again, more of the same thing. Let's look at these two now. So these two add up to 9. These two add up to 19. Number in intersection, number in the union, they add up to 19. See? Those two add up to 19. 19. We put that apart in blue. So these two, this and this, must add up to 19 as well. So the 9 plus the 10 is what will give us the 19. So it is a 10 that is missing right here. This is the 10. Everybody understand that, right? I was doing it
Yes,
quickly.
sir.
Yes, sir.
Yes, sir.
Just doing it quickly
Yes,
as you
sir.
should. Right. All right. The intersection and the union add up to 19. So number in X plus the number in Y must also add up to 19. So it's a 10 that is missing because it gave us the 9. All right. Simple as that. All right. This one now. The Venn diagram shows the shaded region. Shaded region. Shaded region is everything outside of P. So it is P complement. Easy as that. P complement. P complement is shaded. All right. Suppose I wanted the unshaded region. What will the answer be? What I wanted the unshaded region. What will the answer be if I wanted the unshaded? Unshaded area just the P. If the shaded region is P complement, then shaded region is just P. Only the unshaded region is just P. We want the unshaded region to just be set P. Alright. Got this one now. This one is asking us for the unshaded region. So we're talking about here. What is that? The unshaded region. Huh?
Q.
No.
B.
No. So the shaded region, if you notice, is Q only. Q only. That's what it is. Now, Q only means the intersection of Q, you want everything that is in Q, but outside of P. So in other words, you don't want this part in it. So you have to say outside of P. Because you see, if it's a Q, it will be everything, including yourself. But I didn't say Q, I said Q only, meaning I don't want this. And I don't want anything outside here. So it means that the piece of P that falls in Q, I don't want it. So I have to put the complement on it to get it out. So the answer is the last one. I want
It's D.
D. I want what is in Q. This means and. The intersection symbol, the word for it is and. The union symbol is or. Or. The symbol for union, the word for union is or. The word for intersection is and. Intersection. The word for intersection is and. So you want what is in Q and at the same time outside of P. This have a prime on it, you know, if you're not seeing it. This have a prime on it. This is P prime. So this is the answer. Q intersect P complement. This is the one that means Q only. This one. It means you're inside of Q and at the same time outside of P. That's the region that you want. The region that is inside of Q, the unshaded region, is Q only. Inside of Q and at the same time outside of P. And it is written like this. Write it something. Q intersect P complement. Inside of Q and outside of P. So if you notice, you know, everything out here so it's outside of P. But at the same time, you want the region inside of Q. So it's everything outside of P and inside of P. Outside of P and inside of P. That's what Q only is right there. That's the last one. All right, let's continue. Over here. Which of the following is equivalent to this? Equivalent sets have the same number of elements. Equivalent sets have the same number of
Sorry,
members. Yeah.
it would be C. C?
C, same number of members.
Oh,
Same number of members.
so like the same letters?
No, same number, not the same values. Same number, right to the word number. Same number, size is the same. Same number. That's what makes them equivalent. Same number of members or same number of elements. Same number of elements. That's what makes them equivalent. All right, so remember that. Same number of elements. So for example, the number of, all right, so I'm write two sets. So I'm write, for example, A, and A has the values 1, 2, 3. And I write B, and B has the values A, B, C. Then it means that A is equivalent to B. This is a symbol for equivalent. A and B are equivalent. A is equivalent to B. That's what it means, because they have the same number of values. But the number of values in A, the number of values in A is equal to the number of values in B, which is equal to 3. All right. So the set that is equivalent to this one is this one. But I get it? So don't matter what the values are, don't matter what the elements are. Once the number of values is the same, they are equivalent. But I get it?
Yes, sir.
Yes, sir.
Good. So we did this question already. In fact, this is not the same question, it's a similar question, but you don't put the 48 on this one. Change it now. Let's see. Scrabble question. Where is it? The Scrabble question a while ago. Where is it? I will draw it. Didn't we draw it? See it here. So remember the Scrabble question up here, so got it carefully. There was no mention of 48 in there. All right. Let's set a Scrabble question again. You might go and think because it's a Scrabble and you say checkers and anything, it's the same question. But let's look. So the answer for this one was 40, right? Let's look now down here. Let's look for this stuff. I think it's the same question. Let's see what this one says. This one says, all students in a class play Scrabble and checker. I'm going to draw up this one again. I think it's the same question and the same thing, but they kind of reverse information. Right? And that's what they tend to do sometimes.
It would be 16.
They give the same information, but they reverse it. And again, it's percentage. I want to put on 100 again. Yeah, 100%. So the information that is missing, but I like the answer this time. Yeah. Let's make sure. So this is Scrabble and chess. That's what they say now. Let's make sure it's the same thing. All right, it said, yes, Scrabble or checkers are both, right? Means that there's none out here. Everybody play. I say all. So it means that there's none out here, right? That's the first thing. It says 36 plays Scrabble only. So put in the 36 inside this again. 36. And it says 48 play checkers only. So you see the reverse now, they give us a 48 over here. So
16.
checkers only. So they say what percentage play both? So this question is now asking us for the intersection, which is correct. So we have to add up these two and subtract from 100. So it becomes 100 minus the 36 and the 48. That's what you have to look. Everything must add to 100. And that is the 16 that is missing from the original question. All right, so this is the answer. So that's what they do for people who try to swap questions. All right, if you swap the question, I think it's the same question, looking for the 48. Worse them put 48 for one of the answer there. I think it's the same question, I run the mark 48. I know the original question was 48. All right, so that's what we need to make sure we understand what we're doing. And don't just be there swatting answers. All right, so that is it. Everything must add up to 100. I would say because this is 48, the whole of this must be 52. This is already, right? So all of this one must be 52. Right? And so inside this is 16. So we put the 52 minus 36 as well. Could have done it that way. But that's all right, that's good enough. All right, next one. This one says, this one refers to a Venn diagram below. In the Venn diagram, X represents the set of factors of 12, Y represents the set of factors of 9. The shaded region represents the set of factors of 1. So basically, we want to look at the information. What I would do for this one is list them out. And look for and clearly ask for the intersection, right? So let's list them out. So the factors of 12, which is X, I'm going to list them out. Don't forget that 1 is also a factor. So it will be 1, 2, 3, 4, 6, and 12 itself. And then Y are the factors of 9. And don't forget 1. Don't forget 1 is a factor. Factors of 9. So it will be 1, 3, and just 9. Those are the only factors of 9. 1, 3, and 9. And so this now is the intersection. I'm going to underline the intersection. So the intersecting value is 1, 3, 1, 3. So the intersection which is what they have shaded there, which is x intersect y, would be the set 1 and 3. And 1 and 3 are factors of 3 because 3 is a prime number. That's what I said. Are factors of 3. Yes. So 1 and 3 are factors of 3. So it works out itself. That is it. Put on information and it works out itself. All right. Beautiful. This one now. It's another set question. I see it? This set question over here. Same information over here. Almost. All right. So I put them side by side so you can see. See, the diagrams also very similar. See, I have one with a subset there. This one of a subset again. You have disjoint sets, and so on. You have 2 with intersection. All right. So it's the diagrams are similar. Let's read the information for this one. This one says 30 students in teacher May's class have either dog or cat or none of the two. So there are some persons who don't have any. All right. All students who have a cat also have a dog. All students who have a cat also have a dog. So it means that the dogs are subsets of the cat set. All students who have a cat also have a dog. So once you have a cat, you also have a dog. So the dogs are subsets of the cat. That's what it means. All right. It says if the number in C, see that the cat set is 12, and the number in D is 16. Which of the following Venn diagram below is correctly represent information? So first I'm going to look for is the one with the subset. Based on this information, all students who have a cat also have a dog. First thing I'm going to do is look for the intersection, and then check if the numbers make sense. Which is this last one down here. All students who have a cat also have a dog. I wrote it the wrong way around. So once you have a cat, you also have a dog. Means that you're a subset. I don't know if I wrote it wrong, but this is the correct thing. What did they say? They said the number in cat is 12, which is what we're seeing here. 12. The number in for dog is 60, which is correct because you have 12. You also have 12 dogs in here. Once you have 12 in here, you say you have 12 cats, but you also have 12 dogs, and you're also in the dog subset. So this is up to 16. And then the total is 30. Total is 30. So everything must have 30, which these do. That's 16 and 14, 30. So this one look like it, you know. This one look like the answer. Based on information. Let's see if we can eliminate the others. Let's see if we can eliminate the others. Number in cat is 12. This wrong. This one wrong. And number in this cat right now is 14. So that one wrong. Right? So let me mark it. It's wrong because this is showing 14. 14 cat. So this wrong. Cat count wrong from this already. Let me zoom it up. This is 14. So if you didn't know the subset method, right? You could use a process elimination. This eliminates that. This says it's supposed to be 12. That is so no. The number in dog is 12. And the number in cat, the number in dog is 16, sorry. And the number of dog is 12. But the problem is this one don't take care of the subset aspect of it. That's why this one is wrong. But this one is disjoint in them. And the question did say all who have a dog also have a cat. So there must be some intersection based on that. And right now this is disjoint. So this because of the disjoint, obviously this one is not correct because of the disjoint. There's no disjoint based on information. Going here, so this dog is 18. So this can't be right. This add up to 18. So this one cannot be right. Because it did say you must have 16 dogs. It was a 16 dogs only, so 16 dogs. This is 18 dogs shown here. So that's why that one is incorrect. So you could use a process of elimination and get that one. Last one. All right, look over here now. Similar information, almost the same. 30 students in teacher Miss class have either dog or cat or none of the two. 16 students have a dog, 16 students have dog, 12 students have cat, and the remainder have neither cat nor dog. Which of the Venn diagrams correctly represent information? So this one don't talk about any all who have a cat have a dog or vice versa. Not like that. No, there's no subset information. Where it says 16 students have dog, 12 have cat, and the remainder have neither. So we can use a process of elimination again. So right here, so now I can eliminate this one right off the bat. But this is saying that the total in the dog is 16 and that, which is 28. 28 dog that. 16 plus 12. So I can eliminate that. Hold on a second, guys. Hold on a second. 1 second. Give me a second. I wanted to do this in the two. Hold on a second. Give me 1 second, please. Sorry about that. Right, so we can use a process of elimination. It says there are 16 dogs, 16, and 12 cats. Now, right here, so we have 14 cats. So it can't be the answer either. This is showing me 14 cats. And then there must be 12, right? 12 cats. So this eliminates that. Let's continue. This one again, show me 18 dogs. This one show me 18 dogs. See? 16 and 2, 18. Question I must have 16 dogs. So this one is eliminated again. So the answer must be this one over here. Must be by a process of elimination. So even if you don't understand the wording and all of that, that one must be. Right? That one must be the answer this time. 16 dogs, 12 cats, and everybody else don't know. And it add up to, everything add up to the 30. Add up to 30. All right? So basically that is it. Yeah, I am add up to 30 still, but this is the answer. So by a process of elimination. Even if you don't understand the wording of the question, you can use a process of elimination. Just find what goes against the information from each of the sets, each of the diagrams. I eliminate, just three to eliminate, I have the one that is supposed to have. There you go. All right, simple as that. So note, guys, same information, different answers. All right, so you have to read carefully. And you can set it again, yet with other information, such as one of the other diagrams, still is the answer. So if you're not sure, use a process of elimination. Right? Remember, inside yourself is the number in the dogs. So this here has to be 16 in this case. This is 14 plus 2 is 16. All right? So, and this would be the dog only. 14 would be the dog only. And 2 would be the intersection. Cat and dog. 2 dogs and 2 cats in there. All right? 2 dogs and 2 cats. Remember, this one is showing the number of dogs and number of cats. So this 2 inside here so means 2 dogs, 2 cats. All right? All right. Let's continue. We're going yes or no. This one is, so this is a question similar to what we did earlier. It says, in which of the following Venn diagram shows this region? Similar to what we did earlier. So this time no doing the reverse. What does this mean? A intersect B complement. Look at it clearly. A intersect B complement. What does this mean?
A and B?
No. This is B complement. It can't mean A and B. Complement means not in B. Means that you're in A and not in B. That's what it means. In A and not in B. A and not B. That's what it means. You want A and at the same time you don't want B. So what that means? You don't want not B, but you want A. You want me to say in an A. All right, let me put it this way. A and outside B. So you're in A and you're outside B. That's what it means. You're in A and you're outside B. That means A only. That's what it means. A only. You want everything outside of B. But you want to be inside of A. You don't want any part of B. So it means that you only want A alone. Right? So you want A only to be shaded. A only, which is this one. See? Everything outside of B. Outside of B. So it's all around here is outside of B. It means A only. Outside of B, but you want it to be inside of A. So it means A only, which is this one. Outside of B. You want the region that is outside of B, but you want it to be inside of B. It's an intersection, you know, outside of B and at the same time inside of A. So that's why you don't want this part, because you're saying you want to be outside of B. That's what the B complement means. You can't have any part of B in it. You want all the region that is outside of A, outside of B, but at the same time it must be inside of A. That's what the and means. Outside of B and inside of A. So it means A only. Right? In A and outside B. That's what you're looking for. The region that is inside of A and at the same time outside of B. So you don't want the key thing, you don't want intersection. You only want a region that is outside. And you're looking for the intersection. Right? So that is it. A only. You see this? This is just set A. This is just set A by itself, nothing else. And this one will be B only. So if we're writing this one, I'm writing beside it. So this one is B only. So this one will be B intersect A complement. That is B only. You don't want nothing in A, but you want B. This means outside of A and inside of B. That would be complement. This one will just be A. And this one was a union of A and B. This is A union B. That's what this one is. That's what those are. This one is the A intersect B complement. So that's why that is a correct answer. I think that's the last set question. Yep. Then comes the mighty consumer arithmetic. Most of the multiple choice questions on consumer. The greatest variety of questions is in consumer arithmetic. Greatest variety of questions that we said is in consumer arithmetic. So I want to take a 10 minutes break and I will come back and do consumer arithmetic. Okay? But I give it that?
Yes,
Yes,
sir.
sir.
All right. Consumer arithmetic kind of longish and a lot of questions, right?
Yes, sir.
I want to take a 10 minutes break and come back to it. But this might close.
Yeah, which part you post live?
Huh? On YouTube.
Which part?
Graphication on my channel. RAFFICKSHAW. Got that channel for the on the live on that channel, you see it. All right, let me put up the clock and take a 10 minutes break. Hold on. So I'll open the first question. All right, so we're gonna continue right here. I'll put up a 10 minutes clock. All right, so the channel for the live is just find that on YouTube and click on the live. And you see it. This thing can all over, Zoom can all over 100 persons. Well, we're down to 70 persons now still. So. It was 90 something earlier. We're down to 70 now. So this is okay. More persons can come on here then.
Sir,
Yes?
sir, are you gonna send the solution to the papers in the group, sir?
You mean this paper that we're working on today? Yeah, man, I can do that. Wait, you are a student from my regular class? I don't know this person.
No, sir.
Oh, okay. I
No,
don't
sir.
know. I don't know you're gonna get it. You want to see the written solutions?
Yes, sir.
You don't want to watch a video.
Sir,
The video will be there online, you know.
the video. Oh, yeah.
The videos
I can do that too, sir.
Yeah, man, YouTube videos there. That's why I record it online for persons can persons can go and watch it back later and see what they want to see.
Oh, all right, sir.
Yeah.
Yes, sir. I'm gonna watch the video, sir.
Huh?
I'm gonna watch the video, sir.
Yeah, well, you came on late.
No, no, sir. I was gonna
It's
leave
on the
for
look
a
back
minute,
what.
sir. So,
Okay. All right. All right, no problem.
yes, sir.
All right, guys, let's go again. Want to see how far we can get to today, such that finish off this document. By tomorrow, hopefully we can do a paper. Just run through a paper, itself, to finish off. Well, let's see. I mean, this document is good enough still. It covers everything, right? So let's go. All right, so we're in the consumer arithmetic section now. I'll just go straight to it. All right. So this is money matters. These questions are money matters questions, all right? And everybody should be comfortable because everybody spend money. All right, so a lot of the time we think of it a little bit too abstract. But kind of straightforward majority of the time. All right. So this question says, for every $100 sales or part thereof. So after every $100 or part thereof, a salesman is paid $10 as commission. So for example, if he sells $120, he's getting $10 for $100, and the other part is $20. So he's also getting $10 for the part, which is $20. So if he sells $120, he's gonna get $20 commission, 10 plus 10. $10 for the 100 and $10 for the other part. That's what they mean by part thereof. All right, let's continue. It says, if it says for a particular month, where $1,020, it's interesting that I choose 20 a while ago, $1,020. How much commission was he paid? So what I'm gonna know, I'm gonna break down this $1,020 to see how many $100 are in there. And then the part thereof is also gonna get a commission for $10. So look at it this way. So it is the $1,020 can be broken down as $1,000 of sales, which is basically $100 that's enough, plus $20 of sale. Let's shift this over. So this $1,000 is $100 that you know. So him sell $100 10 times plus this $20. So in terms of his commission, let's do it now. In terms of the commission, he's gonna get $10 because for each $100 he's getting $10. So he's gonna get $10. For each of these $100 getting $10. So he'll get 10 of them. Plus he's getting $10 for that $20 sale as well. That's a part there off. So $10 plus $10, this is $100 enough. So you're getting $100 plus $10. So you get a total of $110. That is the answer. But understand that? But good at that?
Yes, sir.
All right. We just want to see how many $100 he had. For each of the $100, you got $10. And then for any additional part that is left,
Sir.
after all the full $100, getting $10 as well. All right. This next one.
Someone said no in the chat, sir.
Somebody said no?
In the chat, yes, sir.
I can't read the chat now. All right. So the question says for every $100 of sale, he's getting $10, but he's also getting $10 for any part of $100. So if he sells $1,020, you want to know how many $100 is in that. Because each $100 that he sold, he's getting $10 commission. So I brought down the $1,020 into $1,000 of sale plus $20 of sale. This is his sales. In this $1,000, there are 10 $100 in it. So like it's 10 times himself $100. 10 times. He sold $100 of goods. 10 times he did that. And then another time he sold $20. So this represents the breakdown of his sales. For each of the $100 that he sold, he's getting a commission of $10. So basically it's 10 times he got $10. 10 times he got $10. Plus he got another $10 for this $20 sale. So the commission, the $10 that he got, add up to $100, plus the other $110 that he got for this $20 sales. Total $1,110. $10 is 100. That's $100. Plus another $10 over here. Can I explain it any better? Person understand it any better in the chat?
Wait, sir, but couldn't you divide the $1,020 by 100 and times it by 10, sir?
Yes. What are you gonna account for the $20? The main thing you want to see how many full $100 you did. That's the key to this question, you know. You want to see how many full $100 you did. That's why I break it out this way. And I want to see how many full $100 you did. Because he's only gonna get, you have to complete the full $100 first. And then they are prepared now to give him another $10 for any additional part. But that is after you complete all of the $100. So you need to see how many $100 fully is in that, which is 10. And then you have another $20 remaining, which is also getting a commission for. So yes, you could do it that way, but I prefer the method where you break it down to see how many $100 you did. Break down the money to see how many times you did $100, which is 10 times. And then in addition to that 10 times that he did $100, he also had a $20 sale. Look at it that way. So for each of the 10 times that he did $100 sales, he's getting $10. That's 10 times $10. That's $100 of commission. Plus he got an additional $10 for the $20 sale that he did. Can I explain it any better than that, guys? I don't have any other words to explain it. All right? Person, understand it any better?
Sir.
All right. Let's move on. This question says the value of a plot of land is $18,000. Land tax is charged at a rate of 0.70 per $100. What is the total amount of tax for the land? All right. A similar kind of question this one. For every $100 in the cost of the land, in the value of the land, you are paying 70 cents. The value of the land is 18,000. So I am interested in finding out how many $100 are there in 18,000. And then for each of those $100, I'm gonna pay 70 cents. So the formula to calculate the value is this, or the method. It is 18,000. Let me if you understand it now. 18,000 divided by $100. That will tell me how many $100 I have in $18,000, which is 180. Then for each of those, I am multiplying by the price or the tax for every $100, the rate, which is 0.70. That's what I'm multiplying by. 0.70. Put it by the dollar sign. That's what I'm calculating, you know. So this is going to tell me how many $100 I have in 18,000. And then for each of the $100, I have to multiply by the 70 cents to see what the tax is. That's how I calculate the tax. The tax is equal to this. This is the number of $100 that is in 18,000. For each of them, I have to pay this. Now this calculation is very easy, you know, guys. You don't have to work it out. You don't have to work it out. Why? Because the answers are there on the paper. I don't have to work it out. The answers are on the paper. All these zeros don't mean anything. The numbers that are relevant to this calculation is the 7 and the 18. I will eventually have to multiply them. The zeros will simply shift around the decimal point here and bring the number down to the size of 100. That's all will happen with the zeros. I don't even have to work it out. I'm in a multiple choice exam. I realize that these zeros will basically just bring the decimal point where it is supposed to be, bring the resulting number within this range. I don't have to focus on that. In terms, the material in this calculation, what is of material, what is of importance in this calculation, is the fact that I'm going to have to multiply this 7 by this 18 at some stage. I don't even have to multiply it, you know. I can look to the 8 and the 7. 7 times 8 is how much? What is 7 times 8?
56.
The only number with a 6 in it is this. See there? When we multiply them two numbers here, you know, the 18 times the 7, you know. 18 times 7, you know. Because the 7 times the 8 is 56. My last digit in my number must have a 6 on it. So the answer must be the one with a end with a 6, which has to be this one. That's why I tell you not everything have to work out, you know. Why? Because the answers are there. The people. Now, see if I see another answer with a 6 on it like that, let me know somebody have to check it more. But this is the only one that ends with a 6. So that must be the answer. I can't use calculator in the exam, you know. So I have to be smart. The answers are on the paper. You don't have to work out everything. As you work, you look at the answers. You understand what I'm saying? I'm showing you how to do the shortcut in the exam. You understand what I just did a while ago?
Yes, sir.
Yes, sir.
Good. You don't have to work out everything. This is 7 times 8 gonna be 56. The 7 times, look here. You see in the 18, it's in the 18 times the 7 that I have to do. The 7 times the 1, this one just going to give me 17, you know. It is a 7 times 8 That's going to be important now. That's going to give me the 56, you know. The 56, you know. That's how them get the 126, you know. See there now. I don't even care about the thing. I just focus on the last digit that I'm going to get. When I look at my answers, all the last digits, well, I have 0 and 0 here, so. And 0 here, so. The only one that end with a digit is that one, you know, which I got from the 7 times 8. I don't have to waste time and work it out. 7 times 8 is 56. So it must be the one that ends with a 6. It must be the answer that ends with a 6. It must be the answer that ends with a 6, because the 7 times 8 is 56. Has to be the answer that ends with a 6. Answer ends with a 6. Here, bam, that's it. Simple as that. The zeros and the decimal point, them just move themselves around and simplify down the number to size. That's all it does. Material in terms of the impact of the calculation, it is the 7 times 18. And I don't need to go to the full 7 times 18. I can go to 7 times 8 first, but that is going to give me what my final digits are in the answer. I'm trying to use a process of elimination. You do have to work out everything in the exam, guys. And going forward, let's see if we can use that approach a little bit. Use the answers to kind of guide us. Look at the numbers that we're working with. All right? You don't have to work out everything right down to the answer. It's not an exam where you show your work. It's an exam where you just want to get to the correct answer quickly. Right? You're not going to show the work, you know. So you have to be smart, get the right answer the quickest way possible. So look at the numbers that you're working with. Right? Know that the zeros basically just move around decimal point and cancel out each other. The numbers are what really change the overall value, or change the look of the value, or change the digits that you end up with. The numbers that you're working with. Understand? Let me take this card. Give me a second, guys. I don't know if... Hello? Yes? Yeah. I'm in a class now, like it. You can just come out of the classroom. I'm in the classroom. I'm in the classroom, so you can bring it to the classroom. All right, cool. Yeah, cool. All right. All right. Sorry about that, guys. All right, sorry about it. Next question. Let's look at the next one. This one says, if the simple interest on $900 for 3 years is 108, what is the rate of interest? Now, everybody knows the simple interest formula. Right? Everybody knows it and uses it. So it is I equals PRT divided by 100. So I won't even try to do it any other way, because I know everybody uses this method. They want us to find the rate. So we'll try to find the R. Remember, the rate is a percentage. So the percentage is here. And the percentage is already taken care of by the 100 under here. So for example, if the R comes out to be 4, you know, it says 4%. All right? Good. Because the percent is already taken care of by the 100 being under here. So represent per annum. So we're trying to find the R in this question. So I'm going to multiply over the 100, divide on the P, and divide on the T. Let's work it down. So the rate is going to be 100 times the interest over the principal times the time. So I'm going to drop the values in this now. Let me work it from right to left. It don't really matter. So all I've done, I transpose away the 100 up here, multiply it up here. I've divided under the P under here, and I've divided under the T. And I've left R as a subject by itself. I'm going to put in the values on this side. So it's 100 times the interest. The interest is this. That's what I said the interest was. So it's 100 times 108. Let me shift this over. And then now I'm dividing that by 3. And I'm also dividing, sorry. I'm dividing that by the principal, which is 900, that is principal, 900. And I'm also dividing that by the time of 3 years. That's what I'm working out in. That's what I'm trying to work out. All right. So again, you know, you can look at the numbers. Look at the numbers that you have. So 108. 108 is a multiple of, it's 12 times 9. So you can cancel it down quickly. So the 100s cancel out each other here. So, right? The 9 into that is 1 time into 108 is 12. So you're basically left with 12 over 3, which is 4. So this works out to be 4. So the answer is 4 right here. That is it. That is it. Now, if I cannot do this calculation, you know, I can use a process of, I can test the answers, you know. So for example, I know that the interest equals PRT over 100. I know so I want the answer to be 108. So we can try the values, you know. I can say, all right, 900, try 4 first, times 3, divided by 100. Now this works, you know why? Because the numbers that are relevant is the 3 times the 4, which is 12. I would say the 12 times 9 is 108. So that I will get my answer right there. So I know that the 4 would have been correct. Right? If I want to use the answers to test which is correct, by plugging the answers in the formula. Plug in the answers in the formula and see which one of them give me the 108 interest. Right? But we don't want to do that. We want to work it out. You know? Work it out like I did here. Work it out. All right, so let me shift the formula up here so I get it. All right, but that is it. All right, next question. This question says, at the end of any year, a car is worth 5% less. A car is worth 5% less than what it was worth at the beginning of the year. If the car is worth 9,500 in December, then the value in January was what? What was the value in January? Now, if it is worth 5% less, it means that the new value is 95%. You're picking out 5%. So let's write that. The new value is 95% of the original value. So what it means, therefore, that's the premise on which you're going to do this question. It means that 95 over 100 times the January value, let's call that J, is equal to the December value, which is 9,500. Question done, you know? Question done. How many question done? Because that 95 here cancel with a 95 there, you know? So everything left is pure zeros. So the answer must be the one with pure zeros, which is this one. I don't have to work it out to completion. It must be the one with only zeros in it. That must be the answer. It's the only answer that has only zeros, one and only zeros. Because the 95 gone. Right? All I'm left with is 100 over here and 100 under here. You want to work it out to completion, then the January figure will be 100 times 100, which is this 10,000 right there. Right? But I could see that the answer is 10,000 right from right here, because the 95 cancels the 95 on both sides. They cancel each other. So I only the answer with only zeros, 1 and zeros must be the answer. And that is it. All right. I've seen a question like this where they actually tell you that the end value, the starting value is 10,000 and they wanted the December value. In that case, you just calculate the 95%. So I've seen that before as well. In that case, the answer will be this. All right. But it's not in this set of questions that I'm giving. I've seen it set that way before. This one says, a man's regular pay is $3 per hour up to 40 hours. All right. Let me see something. All right. This question might be repeated and stuff. A man's regular pay is $3 per hour up to 40 hours. So it means that the regular pay are called the basic pay. The regular pay is also called the basic pay. So it's basic is equal to 40 hours times $3. Is equal to 40 hours times $3. So his basic pay is $120. All right. If he was paid that amount, $216, how many overtime? First of them says overtime rate is twice. Right? They say overtime is twice the pay of regular rate. So overtime rate is $6 per hour. So we can write that. Overtime is $6. That's twice. $6 per hour. Per overtime hour. All right. So if his total pay is $216, so you have to subtract the 120 to know what the overtime pay is. That's what you have to do, you know. The total pay is $216. Included in that is regular pay or his basic pay. So you're gonna have to subtract the $120. So the overtime pay that you got, that's right. The overtime pay is equal to $216 minus $120. 216 minus 120. All right, so you're gonna minus 100 first and get 1, and then you're gonna subtract 60. You're gonna get 96. You're gonna get 96. 96. You're gonna get $96. Right, so that's $96. That's overtime pay. And you got that overtime pay at this rate, 6 hours, $6 per hour. So you have to divide this total overtime pay by the hourly rate, how many overtime hours that you did. So the overtime hours must be equal to the overtime pay divided by the overtime rate. That is it. That must be 16. Yes, because 1 into this is 3 times. No, 1 into that is 1 time remainder 3. And then 6 into 36 is 6. So this is 16. So this is equal to 16. So it's 16 hours that you did. You understand that?
Yes, sir.
All right. So we have to calculate the overtime pay. So the overtime pay is the total minus the basic. And then all we have to do now is divide the overtime pay by the overtime rate of pay to know the overtime hours. And they told us that the overtime is paid at twice. Most times it's the time and a half, you know, but this time it's twice. Most times it's 1.5 is the overtime rate, but this time it's twice. So overtime rate was $6, but the basic was $3. All right, that's it. All right, that finishes that one. All right, try to see if we can pick up the pace a little bit, especially when we come upon questions that are similar to what we've done before. He said, this one said the simple interest on $600 for T years at 5% per annum is 120. What is the value of T? So basically the transposition, again, it is I equals PRT divided by 100 and trying to make T the subject. So T equals, multiply the 100. So you get 100I, and then divide by the principal and the rate. So divide by the principal and the rate. That's what they're working on. So it's 100 times the interest. The interest is 120. Divided by the principal is 600. Times the rate is 5%, 5. That is the T. This is what you're looking for. I gave it to us as a formula. 100 times, see there, so this is it. 100 times 120 over 600 times 5. That's it. So this is just to transpose the interest rate formula, simple interest formula. Next question. This question says, at a bank, EC dollars, EC $2.60 is equivalent to US $1. All right. So this EC is equivalent to US $1. So every $1, you get this amount of EC dollars. It says for every $1 exchanged, for every $1 US dollar exchanged, 10 cents EC 10 cents is deducted as an exchange tax. So out of the 260, you're paying $10. 10 cents. Out of the $2.60, you're paying 10 cents. For every dollar, every US dollar, you're paying 10 cents. So you're actually getting, that's what we write there. You're actually getting. You're actually getting US $1. You're actually getting US $1. That's what you're actually getting in your hand. US $1. You're getting EC $2.50. Okay, you pay 10 cents out of that as tax. So this is what you actually get in your hand. It says how many EC dollar would Leon receive if he exchanged 1,000? So how many of you don't know multiply this by 1,000 because it's $1,000 me get this. So for $1 I get this. So to how much for 1,000? Multiply this by 1,000. Multiply by 1,000 to see how much I get in for 1,000. So it means therefore that US 1,000. So it must be the one with 25 in it. See, I don't have to work it out. Must be the one that has 25 in it just to see, which is this. This must be the answer. So we don't have right now. Let's multiply by 1,000 to get the answer. So it must be that this multiplied by 1,000 is the answer, which is that one. Simple as that. So he's getting 250 because you're taking out 10 cents out of the 260. You're keeping 10 cents out of the 260. So what he's actually getting in his hand is 250 for every dollar because 10 cents gone as tax. So this is what he's actually getting. All right, that is that. Next one. A calculator which is marked at $120 was sold for cash at a 30% discount. How much change would Susan receive if she pays the calculator with a $100 bill? Now, the first thing is how much is she paying? She's going to get a discount of 30%, right? She's going to get a discount of 30%. She pays 70% times the 120. That's what you're paying, you know. 70%. 7 times 12 is what? 84, don't it? Don't it? Material number, and this is 7 times 12. 7 times 12. Everything is cancelled to each other. It is 84. So she basically paying $84. So she gave him a $100 bill, right? Her change that she get back is $100 minus $84. Must be something with a 6. So this is it, $16. This one. Not this one, not that too much. That's it, $16 she get back. But after the calculation, if you get a discount of 30%, guys, you don't have to work out the discount. You don't need to calculate the discount. You just need to know that if you get a discount of 30%, it means that she's paying 30% less. So she's actually paying 70%. So this is what she pays, 70% of the cost of the value of the mark price. So she's paying $84 for it because she gets 30% discount. So she pays 70%. And she give them a $100 bill. So out of the $84, they take the $84 and give her back $16 change. That's it. Any questions on that? Easy question. But okay. All right.
Yes, sir.
All right, let's continue. This one says, a store offers a discount, similar discount again. A store offers a discount of 15%. Let me say paying 85%. If you have a discount of 15%, you're paying 85%. Can't see this so good. All right, let's see if we can see it. It says a store offers a discount of 15% on the total bill to a customer who spends more than, this looks like $20, right? That looks like $20. If you spend more than $20, you get a discount of 15%. Let's put this at 20%. $20. This looks like a $20. Yeah, looks like $20. 20. So if you spend more than $20, you get 15% discount. So basically you pay 85%. If a customer's total bill is $80, how much must she pay? If the total bill is $80, so Mrs. Wang get the discount, you know. How much must she pay? She must pay 80%, 85%. She pays, she get the discount. So she pays 85%, 85 over 100 times the $80. That's what she's gonna pay. But agree with that? Student, do you agree with that?
Yes, sir.
Yes, sir. Yes, sir.
All right. So just a matter of calculating this down, all right? It's a matter of calculating this down now. All right. I just looking to see if I can see an easy way to do it, right? Looking to see if I can see an easy way to do it. If I can sit down and multiply out. The material values to multiply is this times this. All right? That times that. So then when cancel down. 85%. We could have calculated 15% and subtract it, you know. Maybe I want to easily calculate 15% and subtract it this time. Because to calculate 15%, we can calculate 50%. 15%, right? You can break it down into 10% plus 5% and subtract it. Now 10% of this is $8. 10% is $8.
So you're gonna just have 4 times 17.
Yeah, but hold on there. Hold on. There are multiple ways to do it. I'll check this way. So this will be $8. 15% of 8 will be $8. 10% is $8. And then 5% is half of this, which is $4. $4. So that is $12. So this is the discount. We're checking. So you're taking off $12 out of 80. The answer must have an 8 left on it. So the answer must be this one. The answer must be this one. I think this is the easier way this time. Calculate the discount. So sometimes we can do it that way. We have nice values. 15% is a nice value to calculate. 10% plus 5%. So 10% you take off a 0 for this. You get the $8. And then 5% is half of that. So that's how we make up the 15%. 10% plus 5%. That gives you 12. But you can't use a calculator and a guy. So we work out these things, right? So discount is 12. So she pays $80 minus $12, right? Which is $68. Easy this time. Got the discount calculate easy, that's why. Easy calculation. We do the other way as well, but that's all right. $68. All right, next question. At a store, sales tax is charged at a rate of 2% of the cost price of an item. So they take off 2%. So they pay 98%. All right? Pay 98%. The sales tax on a dress that cost 180 is what? So this guy want 2% of this. You want 2% of that. All right, so look, we can do 2% now. So you can do 1% first. So you want 2%, right? So 1%, we say divide this by 100. 1% is equivalent to $1.80. Because this is 180, you know. This is $180. So if I want 2%, I calculate 1% first. 1% means you divide by 100. 1%, you divide by 100. So 2% must be this times 2. So 2%, therefore, 2%, we multiply this by 2. So you get 18 times 2 is 36, so it's just 3.6. So it must be this other answer, $3.60. They're asking us for the tax, the sales tax. The sales tax. They never ask us how much they pay. They ask us for the tax. So calculating the tax. Tax is 2%. So this is the tax. 2%. So calculate 1% first by divided by 100 and then multiply it back to the 2%. Instead of calculating 2% straight. Next question. A man's taxable income is $20,000. This is where this is taxable. All right. He, I think this is at E. He pays tax at a rate of 28%. The amount of income tax he pays 28%. A man's taxable income is $20,000. He pays tax at a rate of 28%. The amount of income tax he pays 28%. That's what they said, 28%. So we're calculating 28 over 100 times the 20,000. But look how we can work it down quick again. We can work it down quick. You can find 1%, you can find 10%. But the 28, you know, instead of doing it, all right, it's easy because in terms of the material number to calculate here is 2 times 28, which is 56. So the answer must be this one. Those are the numbers they're multiplying. Right? Because it's 2 times 56. Everything else is zeros. So the answer must be the one with the 56. The 2 times 28 is what's going to give it a 56. And then the zeros work out themselves to give it those two. Because these two zeros cancel these two. Right? So the zeros work out themselves. So in terms of the numbers, it's 2 times 28, which is 56. So leave it at that. Bring it the easy way. Right? So I'm breaking it down. This one says, a man's basic wage for a 40-hour week. For a 40-hour week is this. This is basic wage, 160 for a 40-hour week. You know what that means? To get the hourly rate, you have to divide this by 40. So you can write that right here from now on. The hourly rate. All right, so the basic rate. Basic rate. They didn't tell us that. The basic rate is 160 divided by 40 hours. That's $4, you know. $4. So it's paid $4 per hour. Basic, right? Because he gets 40 hours, he earns $160. He is paid $5 per hour for overtime. $5 per hour for overtime. If he works 6.5 hours overtime in a certain week, his wage for that week is total wage for the week you want. So he's paid 5 hours overtime. So you have to multiply. He's paid $5 for overtime and he works 6.5 hours. So you have to multiply these two to know the overtime pay. And then add the 160 to it. So we don't need this. I'm going to show you where we need this. And this is another question. Let me shift this over. And that thing that I've shaded over here, another question. That's something different right here. But for this one on the screen, right, it's simply become because they gave you the time and they gave you the overtime. They gave you the overtime rate and gave you the overtime hours, which is a 6.5, and also give it the basic. So his total pay is going to be 160 plus 5 times 6.5. 6.5. 5 times 6.5. That's what we're working on. 5 times 6.5. Well, 5 times 6.5 is the same as 5 times 6 plus 5 times a half. And 5 times 6.5 right here. It's 5 times 6 plus 5 times a half. So it becomes 160 plus 5 times 6 plus 5 times half. So I work it down quick in an exam. So this is 160 plus 30 plus 2.5. And 2.5 is like 2.50 because it's money we're talking about. So this right here so is 190 and then $2.50. So it becomes 192.5. which is this answer down here. So. All right, now look at this question right here. Son. This question right here. Let me shift this up a little bit. Let's shift this up a little bit. All right, take it off of that. That's how we get that. Put on the 0 here. So 160 is the basic plus the overtime. This is the overtime. 5 times 6.5. 5 times 6.5 is 5 times 6 plus 5 times half. 6.5 is same as 6 plus a half. Well, this question down here, so this calculation becomes relevant. That's why I put it here on the screen. Look at it. Same question, you know. Well, this time instead of telling you that overtime is $5 as they did here, they tell you that the overtime rate is 1.25. It's the difference. That is still $5, you know. 1.25 is the overtime rate. Right? So that's why I needed the overtime pay as $4 here. So I divide the 160 by the 40 to get the basic rate. Then the overtime rate now, the overtime rate that is getting paid is 1.25 times the basic is equal to $4. $4 times 1.25. 1.25 times $4. We'll do a calculation and quick on the exam. Is 1 times 4 plus a quarter times 4. That's what it is, you know. 1 times 4 plus a quarter times 4. In an exam that you can't calculate that. That is $5 still, you know. But this is $4 and this is $1. So this equals $5. So it equals $5. So this is the same question. Everything comes back the same. So this is same $5. Right? So this becomes the same as before, same answer. Right? Same answer. So the answer is the same thing. Same question asked another way. Right? So this is the same answer. Lead to the same answer. Lead to same answer. But understand that? Just that this question gave you the overtime rate of $5. This one tell you that it is time and a half, and it did not tell you $4. So if you get one like this, you have to calculate the $4 and then calculate the overtime rate. And then the rest of the calculation will be the same as we did. But it's still asking for 6 hours, 6.5 hours of overtime. Just that you had to calculate the overtime rate of $5 instead of them giving it to you in this case. Yeah. All right, very good. That's showing you the similarities and the differences with these questions.
So where you get it, sir?
Huh?
So I'm not really see how you get the 192, sir. Do that part there again, sir.
Oh, we get the 192 up here, sir?
Yes, sir. Do that part there again.
All right. So you know, so the basic is 160, right?
Yes, sir.
Plus 5 hours overtime and overtime, 6.5 hours of overtime and overtime rate is $5. See that?
Yes, sir.
So it becomes 5 times 6.5 or 6.5 times 5, whichever you want to look at it. This is the money. And this is the money. This is the hours. See that?
Yes, sir.
So how do I do this calculation? The 6.5 times 5. It is the same as, so put back the 160 plus. It is the same as 5 times 6, but the 6.5 right here, you know, is the same as 6 plus half, you know. You want to break it up, you know. So it becomes 5 times the 6, which is 30. Plus 5 times the half. $5 times the half. So it becomes 160 plus this 5 times 6 is 30. So reach 190 already, you know. And then half of 5 is 2.5. Half of 5 is 2.5. So this becomes half of $5 is $2.50. $2.50. And then you add up all of this, you get $1.95, $192.50. See it?
I see it, sir.
All right. Take this off. All right, that finishes that question. All right, let's continue here. This one says, oh, this is the same question we did that one. So this one don't have it. It's a repeat. Don't have to repeat this. It's a repeat. I think the answer was 8. We did it over here a while ago. So our questions repeat. That's what it is with these things. And so that is a repeat. We did it earlier. I know we did it. I got the 8. And it's 8, we got our 16 over here. See it yourself. Right, one of the first ones that we did. See it here, same question. Same question. Alright, right here. Same question. Alright. So how many overtime? So that's a repeat. So we're going to skip over that one. This one says, a store offer a discount of 10% to customers who spend more than. So this is now 10%. And we did one a while ago, it was what, 8%? Where is it? Store offers a discount. See, this one is now 15%. Same thing, you know. This one is saying 10%. This one is saying 18%. A store offers a discount of 15% and the same $80 bill. But this time it's only 10% the offer, which is easier. 10%. Right? So it's the same question, but the value is different. 10% instead. A store offers a discount of 10% to customers who spend more than $20. If a customer total bill is $80, what will he actually pay? He's gonna pay 90%. And this time this is 72 answer. We're gonna pay 90%. Our 10% is $8. 10% is equivalent to $8. That's a discount. That's a discount. $8. $8. 10% of 80 is $8. 10% of 80 is $8. So he pays $80 minus $8, which is 72. But we calculate another way. Let's do the other way with this one. So since he's getting a discount of 10%, he pays 90%. He pays 90%, which is 90 over 100 times the $80. That's what he pays. And then if you multiply the 9 times the 8, you get 72. So the answer must be the one with 72 right here. That is it. All right, that's what he pays. Get a 10% discount, so he pays 90%. This next question. A man's annual salary is $45,000. His tax-free allowance is $13,000. So he gets this. Tax-free allowance means you subtract this amount before you start to charge tax. There's no tax on the 13,000. So you take out the 13,000 and give it to him without any tax. And then the remainder is tax. That's how tax-free works. It says he has to pay a tax of 20% on the taxable income. The tax payable is, what is the tax? So you first need to calculate taxable. Taxable amount is the 45,000 minus 13. So the taxable becomes 45,000 minus 13,000. Let's do it like this. 45,000 minus 13,000. I'll just show you the work. So that works out to be 32,000. That's the taxable amount. 32,000. And he's paying 20% on that. 20%. Now if he's paying 20%, you know, it must be the number of 2 times that, 64. So this must be the answer. You know? I don't have to do any more work. If I'm going to calculate 20% of that, I'm going to have to multiply the 2 by the 32 to get 64. So this must be the answer. I don't have to go any further. But let's say you're working it out. So the tax, right? The tax payable will be 20%, 20 over 100 times the 32,000. All these zeros are immaterial to the outcome. What is important to the outcome is this 2 times 32, which is 64. The zeros just cancel down to bring us down into the thousands. So that is it. I just need to multiply the 2 times 34 to see what the answer is. Because all the zeros will do is just reduce the size of the overall number. Which is 2 times that is 64. 2 times 32 is 64. So the answer must be the one with the 64 in it. That is it. All right, that's 64. Multiply them. So that is important. Next question. A dinner at a restaurant was advertised at $60 plus 18% tax. The total bill is what? So basically, you're paying $60 plus 18% tax. That's how this calculation goes. Now, you're actually paying 118%. You can calculate that way. But maybe that is too much work. Right? So what does you pay? What do you pay? You pay the $60 first. Plus 18% of $60, which is 18%. 18% of $60. 18 over 100 times 60. That's what you pay. That's what you have to work out. All right? I'm just looking how we could maybe do it quickly. So if I'm pausing, I'm looking how we could maybe do it quickly. All right? So I know these zeros will cancel each other. All right? And then you're really doing 1.8 times 6. That will be divided by the 10 is 1.8 times 6. Or you can do the 18 times 6 and divide by 10. Let me cross out to the red. So it stays there. So I'm canceling this with this. And if I divide by this 10, it becomes 1.8 times 6. All right? So let's set it up that way. So it becomes 1.8 times $6. 1.8 times $6 is 1 times $6 and then 0.8 times $6. So you can look at this as $60 plus 1 times $6 plus 0.8 times $6. $0.8 times $6. Now this is $6. So this becomes $66. 60, right? $66. $66. Plus, now what is this now? 0.8 times 6 is more than half. So that is $4.48. 68 are 48. 6 times 8 is 48. That becomes $4.80. $4.80. $4.80. So you're adding these two now. So you get $70.80 this one. $70.80. Maybe I do too much work with this one, maybe. Who knows? That is it. Can be worked out. Understand it, guys?
Yes, sir. Yes, sir.
All right.
Yes, sir.
Yeah. I was looking to see maybe now pick away, but it's all right. All right. We could have multiplied the 6 times the 18 first. And the 6 times the 18 will basically be 6 times 10 is 60. So 60 is 48. So you will basically get 108. And you get 108, you divide it by the 10, you get 1080. So it will be 1080 plus the 70. So it could be done that way as well. And you get the same answer. But all right, that's okay. I will do some of these things in the exam anyway, take it. All right, that finishes that one. This question now. I don't know how this end up here now, because this is still consumer arithmetic, but it end up here, so I'm gonna do it still. It's a variations question. There's another one down on page, I think either 56 or 46. But that's a variations question. I'm gonna do it right here still, even though we're doing consumer arithmetic. I'm just gonna do it now still, right? This really should be in the next section. but I'm still gonna do it now. It says, give me that y varies directly as x. This statement means y is equal to a constant times x directly. Directly means y times. Y equals a constant times x. If it was inversely, if instead of directly it was inversely, you write y equals k divided by x. All right? Y equals k divided by x. The question says, and y equals 18 when x equals 152. All right? 152. Which of the following equation represents a relationship? Now, see this information that I gave you right here? It's for you to use it to find the k. You want to use this information to find the k. That's what that is for. To find the k value, the variation constant. That's why they give you that information. So the k value really, look at it, the k is really equal to the y value over the x value. Right? So the y value is 19 over the x value of 152. Now looking at the answers, you know that. Looking at the answers, right? Now look at the answers. I say it's 8 times. Yeah, but this, you know. So I'm gonna check if 8 times this equals that. Now 8 times the 10 is 80. And 8 times the 7, 8 times the 9 is 72. They add to 152 for real. So that is 8 times. So I confirm that it is 1 over 8. So all I need to do is drop by the 1 over 8 right here. So I have my formula. Right? So I'm going to write about the formula now. I said the formula is therefore y equals 1 over 8 times x. So the answer is this one right here. If I can try it, drop the 152 right this up and test it. I do 152 divided by 8, which is 90. So you know, say it right. But that is it, guys. All right, that's that one. Let's look at another one. This one says, the distance L that an elastic string is stretched by hanging an object of mass m varies directly as the mass m. So what this means again is that the length is equal to a constant times the mass. The length of this elastic is equal to a constant times the mass. Okay, it's common sense in this question. It says if 5 kilograms stretch the elastic 31 centimeters, how far will 29 kilograms stretch it? You can do a ratio up, you know, because you see this is almost 6 times that, you know. So therefore the stretch is going to be almost 6 times this. Right? It's almost 6 times that. So don't have to do no calculation. You can just do a ratio, so ratio it up. See here, 5 kilograms give you a stretch of 31 centimeters. I want more 29 over there. I can look at 30 though. Let's multiply this by 6 and see what 30 do. And get the closest answer to that, which is actually less than it. Because the 29 kilogram will give you less than what 30 do. So I'm looking for the closest value that is less. I'm going to multiply this by 6. And see what 30 do. Because this is going to give me 30. Multiply it by 6. And just look what 30 do. And look for the closest answer to that. So this is going to give me 30 kilograms. We're going to give me, multiply this by 6. Multiply this by 6, we get 6. And then 6 is 80. 186 centimeters. So I'm looking for the answer that is less than 186. See this one? That must be the answer now, guys. Must be the answer. But understand that?
Yes, sir.
So we don't have to complicate it. The answer is on the paper. Remember, the answer is there on the paper. The answer is there on the paper. Right? So 5 kilograms give me this amount of stretching and a direct proportion. It means that I'm going to multiply up this. This going to multiply up this. So 10, in other words, 10 going to give me 62. Then 15 going to give me 93. and so on. So just carry it up, you can carry it up. And you can actually find this too, you know. But no matter, we don't have to find this. Just work easy numbers, carry it up to 30. And get the closest answer, which is less than 180, which is the last one. It can't be this one. Make sure it's not that one. Calculate it and make sure it's not that one. Because what means that the constant must remain. This constant must remain. So the length over the x will always be equal to a constant, right? So right now the length of 31, I'm just checking the answer. 31, it must always be a constant. So I'm saying the 31, the length is 31 over 5 equal a constant. Let's work it out. 31 over 5. Work it out on my phone right here. 31 divided by 5. Same as 62 divided by 10. So it's 6.2. 6.2. Right? And then now, over here now, I'm going to multiply the 6.2 by the 29. That's what we get. And so 6.2 times 29. See that? This is correct. That is correct. I just checked it, guys. It is correct. Let's check it. It's correct. But I think for the purpose of a multiple choice exam, yeah, this calculation is good enough. I have to get it. Look for what 30 give you. Look for the value that is less. All right, that is less. All right. That's how I will do it in the exam. I'm not going to try to work out the exact thing. You don't have to work out the exact thing, guys. You don't need to work out the exact value. Right? The answer is on the paper. You don't need to work out the exact value. All right. This one says a man pays 60 cents for every 200 meter cube of gas used, plus a fixed charge. If he pays $178, $178.75, when he uses $55,000 of gas, how much is the fixed charge? All right. Let's break it down. So I want to know, since he uses $555,000, and for every $200 he pays 60 cents, we can know how much he actually pays for the gas, using those, And then all we have to do, find out how much he pays for the gas, and subtract from that. So this amount minus the amount that he pays for the gas is the fixed charge. Because this is the total that he pays. But understand that reasoning? I'm going to find out how much he pays for the gas using these figures. Right? When I find out how much he pays for the gas, the difference is a fixed charge because he would have paid more. So the amount less than this that he pays is a fixed charge. Let me work it out. Maybe if I finish work it out, you understand. So I'm going to work out what he pays for the gas first. I'm going to work that out first. For gas. He pays. So first thing you want to know how many 200 meter cube is in this. So I have divided. And for each of the meter cube, you pay this amount, 60 cents. So for the gas, the total gas he used was 55,000. 55,000. And he's paying by 200, paying by portions of 200. So it's going to tell me how many 200s is in 55,000. And then for each of those is paying 60 cents. Now, you don't work in cents and dollars at the same time. So this 60 cents, you have to write it as $0.60. You put that dollars. You don't work in cents and dollars at the same time. So I want to put 0.60 and put the dollar sign. $0.60. And we're working this down now, guys. So we can cancel it down. Remember, we can use the calculator. That's what he pays for the gas. We can use the calculator, so you have to work it down. So we're going to cancel this down with that. Because this don't have to calculate this one exact now, right? Because we have to subtract, get that value and subtract it from this to see what the fixed charge is. And then now we're going to do 2 into this and 2 into this and get 0.30. Go make the calculation interesting now. See this 0 right here? I'm going to use that multiply the 0.3. And I'm going to end up getting just 55 times 3. That's what it reduces to. 55 times 3. This 0 right here, like a times 10, it's going to move the decimal point for me and make it become 3. I'm going to go 55 times 3. Oh, the 55 times 3. 5 times 3, do it here so quick. It's 3 times 50, which is 150. And then 3 times 5 is 15. Can I use a calculator at 165? So he pays $165 for the gas. That's what he pays for the gas, 165. So the fixed charge has to be this amount minus 165. This is what he pays for the gas. This is what he pays total. So the difference must be the fixed charge. So the fixed charge must be the 175. Put it over here. Put it over here. Let me shift this over. Because I want to leave it on the document. I want to leave the working out on the document. So the fixed charge now has to be the 175. 178, sorry. 75. I know the answer already. Must be the one with the 75, you know. Must be the one with the 75. Because I'm subtracting a whole number here. You saw? Yeah, I'm subtracting a whole number. I'm subtracting 165, 00. Subtracting. So it must end with a 75. So I don't have to work anymore. It must be this one is the answer. But it's going to give me 30 instead. I subtract it. That's my fixed charge, 1375. You can understand the calculation, guys?
Yes, sir. Yes, sir.
Understand it? All right, good. So let's work out how much you pay for the gas and then subtract from the total that you pay. All right. This one says, a plot of land is presently valued at $12,000 and it appreciates in value. Appreciate means get more. At a rate of 2.5% per annum. What will be the value of the plot of land in 1 year? Answers on the paper. This is 12,000 coming from it now. If it appreciates, it must get more. I don't have to do no calculation for this. Can't be this, that is less. Can't be this, that is less. Can't be this, that is less. It has to be that one. I don't have to calculate nothing. Must be the one that is more. Because appreciates means that it gets more. The answers are on the paper. Not everything has to be worked out. You want to waste time and work it out, fine. It appreciates by 12, by 12. So if you want, you can calculate 2.5% of 12,000, you know, so if you want to calculate it. But this don't need no calculation because this is the only value that is more than 12,000. If it appreciates, it means that it grows in value. So it cannot be any value that is less than it. It appreciates. Not depreciate, it appreciates, but it will be 2.5 over 100 times the 12,000. That is the appreciation. That's the amount that it appreciates by. All right, that's the amount that it appreciates by. So really working out the 12 times the 2.5, or 12 times 25. That will give us a 300, 2.5% per annum. I'm not going to give us that. Let me see what is that mean here. What will be the value of the plot of land? Plot of land presently valued at 12,000. Appreciate at a rate of 2.5% per annum. Yeah, that is 300. Yes, so divide by the 100. Oh yes, 2.5 times this. 2.5 times that. 2.5. This is 2.5 because the zeros will cancel. You're looking at the number too largely. So it's 2.5. It works down to 2.5 and work it out. It works down to 2.5 times 120. Right. That's when the zeros cancel. The zeros cancel there. 2.5 times 120. To do this quickly, it's 2 times 120 and then half of 120. So if you want to do this quickly in an exam and work it out, it's 2 times 120, right? 2 times 120. I can use a calculator, and then 0.5 times the 120. Without a calculator, these are the things you have to do. So this is actually 240, and this is actually 60. That's how we come to 300. So that is the increase. But as I said, this was the only possible answer that was correct. Right? So never actually work it out. This is the amount that you appreciate by $300. All right, too much time on that. Next one says, a loan of $8,000 was paid back in 2 years in monthly installments. And let me make a note. I've seen this question that instead of saying 2 years, said 24 months. 24 monthly installments or something like that. I've seen a question that says 24 months instead of 2, which is the same question with that. It says a loan of $8,000 was paid back in 2 years or 24 months in monthly payments of $400. The interest loan as a percentage was, I don't want the interest as a percentage. First thing I want to know is the interest. Right? So the interest is the total amount paid back minus the original amount. The interest equals 24 times $400. That's total amount paid back. Total amount paid back is 24 times $400. That's the amount paid back, you know. And you subtract the $8,000 that was originally borrowed. Now what is your code to? 4 times 2 is 80. And 4 times 4 is 16. That's 96. That's 96. So that works out to be 96. That's what I have to multiply, guys. 4 times the 20 first, that's 80. And then 4 is 16. They add to 96. And then put on the 200s for them 2 0 there. So that's why you have to do it in the exam without a calculator, quick and fast. So this is 9600 minus 8,000. So the interest is 1,600. 1,600 is the interest. The more the interest is a percentage. So the percentage interest, and it's of the original amount, is the 1,600 divided by the 8,000 multiplied by 100. That has to be an answer with a 2. Because 8 into 16 is 2 times. All of them 0 here, work out them one another. There has to be an answer with a 2. 8 divided by 16 divided by 8 is 2. So it has to be the answer with just a 2. See here, 20. That is it. Answer is 20%. You have to work out everything to completion, guys. The important numbers here in this calculation is the 16 divided by the 8. The zeros work out themselves. And I give 2 or 20 or 2, but it's 2, 20 grand. 20 grand. 20%. Eh? This on the size of this. 20%. All right, so that is that. You have to work out everything to completion. Remember, not use the show working. An article is bought for $125 and sold for $125 and sold for $175. The profit as a percentage of the cost. Now, clearly, 125 to 170, that's $50 profit. We don't need to calculate that. So the profit is clearly $50. That's obvious. At this level, most can see that. We don't have to calculate that. Profit is $50. So the percentage profit is the $50 profit over the original amount of 125. 125. Express that as a percentage, multiply that by 100 to get that percentage. This can divide through by what? This can be divided through by 25. 25 into this is 2. 25 into this is 5. And then 5 into this is 1, and 5 into this is 20. 2 times 20 give you 40, so that's 40%. 40%. But go to that. But okay?
Yes, sir.
Yes, sir.
All right. What time is it now? Maybe we're going to stop off at this topic, you know. Start back tomorrow. Start back tomorrow. You know, so when I reach nowhere yet, this thing have, although the lot of questions have less questions per page. We can move faster. Let's continue. This one says a simple interest on a sum of money invested 5% per annum for 3 years was $90. What was the sum of money? So this one they're asking us for the principal. Same formula again. I equals PRT divided by 100. This question, we know the interest, we know the rate, we know the time. Remember, the time has to be in years. So if you're doing a question, for example, instead of 3 years, it's going to put 24 months, for example. You know, so the time equals 2. Time has to be in years. Then put 36 months. You know, so it's 3 years that. Time is 3. If I put 6 months on a question, you know, so the time equals 0.5, half a year that. Time has to be in years in this formula. Has to be in years. Sometimes they give the question with months in it. You have to convert the months to years, divide by 12. All right. So for this question, we're trying to find the principal, right? The amount invested right here. So again, we're going to transpose away the 100 and get 100I divided by the rate and the time. The rate and the time equals the principal. And just plug in the values now. Let me shift this over. Let me shift this over because we're working it from right to left, you know, and it really matter. So we're working it this way. So this becomes equal to 100 times the interest of $90. Let's put the 90. We don't say dollars we're working. So 100 times 90 divided by the rate of 5, and the time is 3. Time is 3. And let's work this down. So cancel it down. You can do the 90 divided by 15. Okay, let's work it down gradually. And that is what, 6? This is 6, right? So this is 15 into this, give me 6 times. That's correct?
Yes.
Someone say yes, someone will go on. So I'm not pay attention now.
Yes,
This cancel and this give me 6 right here. So that's 600, right? 6 times 100 is 600. That's it.
Yes, sir.
All right, good. All right, that is 600. Nice and easy. Let's move on. So the question here again. Man pays 60 cents for 200 meter cube. And after so they reverse the question now. No, they give it a fixed charge. See? No, they give it a fixed charge. So it's the same question, but they reverse it. So it's how much does a man pay when he uses 55,000 of gas? So now the answer is gonna be this. And the question was give us this as a charge, right? But how would be the work? You have to calculate the amount of gas used and add the fixed charge to it. So he pays a fixed charge of $13.75 plus the gas charge. And the gas charge is 55,000 divided by 200, and then multiply that now by the rate of 60 cents. 60 cents again, remember, you don't work in cents, you work in dollars. So we change it to dollars and put 0.60. All right, and you work that down. So I think this came to 600. I'll work it out. I don't want to have to calculate it all over again. I will just do the question a while ago. Not 600, 165. It is 13.75, and this came to 165. If you cancel it, 165. It came to 165 because we ended up multiplying. We ended up multiplying 55 times 3. If we cancel it down, these two cancel with these two. This 0 turn this, well, firstly, and then this cancel to this, give me 3 times which is 0.3, and then the 0 turn this into a 3. So that's what we ended up with. All right, so that is that. It becomes 55 times 3, which is 165. So the answer is the A. So the same question, but they kind of reverse it, right? They kind of flip the information a bit. That's it. And that's what they do from time to time. This question now, it says, refers to the following table, which shows the rates charged for by an insurance company. So house insurance is 25 cents per $100. Remember, the 25 cents is going to work with dollars, right? 0.25. And then content insurance is 50 cents for $100. It says, how much does a person pay for insurance if his house is valued at 50,000 and his content is 10,000? All right. So you want to know how many $100 in this, and for each of them you're paying 25 cents. So it becomes a house plus the content, right? So the house is 50,000 divided by 100, because for every $100 you're paying 25 cents. Multiply that by 0.25. Plus the content now, again, is 10,000 divided by 100. You want to know how many 100 access 10,000. Let's write 10,000. Divided by 100, and you're paying 50 cents, which is 0.5. 0.50. That's what you're working out now, guys. Simple as that. Host plus content. Host plus content. This is the house. This is the content. And let's work this down. Simplify it down and work it down. So material now, you is 1 multiply 5 times 25. 5 times 25 is 125. So this is 125. Plus, you say you really multiply by just 50. By just 50. And all these zeros cancel each other. Then 2 0 move this and 20 to 50. So this is why you say it becomes 50. Plus 50. So that says 175. 175. All right. All right. So much more page on this video. Wow. There's a lot of these questions, you know. A lot of these questions. Like, we have to come back to this tomorrow. To this topic. Start back tomorrow, this topic. As we're coming close to the time. We have about 20 minutes left. All right. Let's work on it. Come back tomorrow. If necessary, if tomorrow is still not enough, still have Monday. Do a session Monday afternoon just to see right to the exam to finish it off. All right, but we'll continue. This one says $7,000 borrowed at a rate of 5% for 3 years. Same formula again. I equals PRT divided by 100. Maybe I put in too many of these on it, but that's how it is. Maybe it's too many of these on it. They're the same thing all the time. The principal is 7,000. Let's leave out the other sign. Let's put the 7,000. 7,000 times a rate of 5 times a time of 3, and divide that by 100. 100. Which of these values is important? 21 times 5. 21 times 5. Looking at the values. 21 times 5. That's 105. So this is the answer. 21 times 5. 7 3 is 21 times 5. I do have to work out everything. 105. The important value is to multiply 21 times 5.
Sir,
Yeah? Yes?
we'll work it from this way.
Oh,
Um,
no. Wrong.
Yeah, man. Yeah, man.
So the answer is 1,050.
Yeah, man. Sorry, my mistake. This is the answer. Yeah, that's it. Thanks. Yeah, because this becomes a 10. So you need the additional 0. Yep. Boom, boom, boom. Right, so it's actually 210 times 5. 210 times 5. All right. Next one. A dress which costs $180 is being sold at a discount of 10%. How much is the discount? The discount is just 10%. Discount is just 10%. 10 over 100 times 180. Let's take off a 0, right? Which is $18 right here. Quick and fast. $18, 10%. Just take off a 0 of this. That's it. The cost of a refrigerator is $18.50. A buyer who is given a discount of 5% for cash will pay. You will pay 95%. You can calculate the 5% and subtract it. You can calculate the 5% and subtract it. Let's do it that way. So we're doing 10% first. So 10% is equivalent to $185. So 5% is half of that. 5% is gonna be $92.50. That's right?
Yes, sir. That's great.
So you subtract $92.50 off this. So it pays $92.50 off. So we can eliminate some answers, you know. So this can be it. It's more. So it must be the answer with a 50. So it can't be this one. Must be the answer with a 50, right? And it can't be this one. So this must be the answer. This must be the answer right here. This can't be it. Too low. And you can't find the take off. So that must be the answer right here. I must subtract some with a 50. Must have an answer with a 50. Right? So that must be it. But I agree with that. By a process of elimination. Students. Huh? But I agree with
Yes,
that.
sir. Understanding.
Yes,
Right.
sir.
Not everything have to be worked out, right? You look at the answers. It can't be this one because this one more and end with a 50. Answer must end with a 50, you know, because if you do this minus this, you must have a 50 left, a 0.50 left. The only answer with a 0.50 that is less than the original amount is that. So that must be the answer. So you don't have to work out everything. All right? You don't have to work out everything. All right, this one. This one says TT $6 equivalent to US $1. What is 15? What is 15 TT? All this can be worked now. All right, so see here, TT to US. TT to US is 6 to 1. I want this to become 15. I want this to become 15. And see what this side become when it become 15. I want the TT side to become 15. All right, so we're gonna become 15. It's actually 2.5, you know. 2.5. I need to multiply it by 2.5. Yeah. 15 is 2.5 times this. Because 2 of this is 12. And half of it is 3. So 12 and 3 give me the 15. So it's 2.5 if I multiply it by. So multiply this ratio by 2.5. 2.5. That will make this side become 15 and this side becomes 2.5. So the answer is $2.50. That's an easy way to do it. Let's multiply this up. If you like, you could divide by the 6 first and get 1 to 1 over 6. And then multiply by the 15. So you get 15 over 6. I could just divide the 15 by 6 one time from the get-go. Could do that as well. All right. Well, that is it. What is that? Next one. This one says EC $2.50 is equivalent to $1. What is EC $20? So again, you can just multiply this up. So EC to US, and it's $2.50 to $1. Multiply this up. Multiply by 2 first, get up to 5. Multiply by 2 first, get up to 5. So we get 5 to 2. And then we want to get up to 20, we multiply by 4. multiply by 4. Multiply by 4, this becomes 20 to 8. So the answer is 8. Understand that, guys? I could just divide these two and get the 8 to stay.
Okay, all right, sir.
We'll divide the 20 by the 2.5. But I like to just, take the ratio and just bring it up to what I want. So I can see what the outcome is. Because USD exchange rate is can be done like ratio questions. I do them like ratios. Just multiply them up to get what you want. That's all. Next one. At the end of the year, a car is worth 5% less than it was. Oh, this is the same question again. Do this is a repeat. All right. Do this already. The answer was 10,000 right here. Right. The same 95,000 at the beginning of the year it was 10,000. Because 95,000 is 5% less than 10,000. So that's a repeat again. This one. A car's present value is 12,000 depreciated at 10%. What will be the value after 1 year? We do this question already too, don't it? We do this question already too. It's a repeat. We're taking off 10%, and the percentage is different. A car present value is 12,000. It depreciated at a rate of 10% per annum. What will be the value at the end of 1 year? Yeah, it's gonna be 90%. I'm gonna repeat this to you. Put on around it. I look and see it's a repeat. It's a repeat. But it's gonna be 90%. So you're doing 90 over 100 times 12 times 12,000. 9 times 12 is 108. So it has to be the first one. It's the only 108 in it. It has to be this. 9 times 12. 108. The zeros cancel each other. So let's go again. No, just what wrong order. These zeros cancel this. Right, and then you get the 1 and 2 zeros here, so for the 2 zeros. So 108. That's it. 108. 9 times 12. 108. Next one. This one says the annual interest rate on a mortgage on a house assessed at a value of 250,000 is 5 cents in every dollar. What is the interest paid on the mortgage for the first year? All right, 5 cents in $1. Again, for this 5 cents, you're gonna work with dollars. So the 5 cents is gonna write it as $0.05. So it's like 1 cent. $1, sorry, $1 of value. You pay 0.05 cents. $0.05. $0.05. You want to know what you pay for 45. So you basically multiply it by the 45, 450,000. Right? You multiply by the 450,000 times 450,000. So essentially, you're multiplying the 5 times 45. And then look at these values. 5 times 45. The zeros will work out themselves. So we just need to work out 5 times 45. 5 times 45. What kind of number will it? Right? The 5 times 40. 5 fours. 5 times 40 is 200. And then 5 times 5 is 25. So the number that has 225 in it is 225 in it is the answer. Which is this one. This is the only number with 225 in it. But understand that? But understand that? $1 is for $1 you pay 5 cents.
Yes, sir.
So for $450,000, you're going to multiply this times this. But the values of note in this calculation, all these zeros will do is move this decimal point over, right? So you really just want to multiply the 5 times 45 to see which are the values you ended up with those corresponding digits. Right? The decimal places work for themselves, especially when they're unique like this one. So it's a 22500. That is it. All right. Next one. Next one says, a dinner at a restaurant was advertised at $60 per. Do this out. This is another repeat. All right, so we're not skip over the repeat. We just do one like this one. We'll add on the 18%. We'll add on the 18%. Just do it out. Just do it out. So this is some of these questions repeat. All right, next one. It says, at a sale, each book was marked at $3 off the original price. Daniel paid $46 for 2 books that had the same sale price. What was the original cost of one? All right. So remember now, he pays this for 2 books. So if he paid that for 2 books, 1 book, that's how much for 1 book. For 1 book is $26. Is $26. No, $23. After that, $23. $23. 23. But then you got a discount of $3. You got a discount of $3. So we add back the discount. Add back discount to get what the original price was. So we're gonna add back the discount. Not putting discount right. We're gonna add back the discount to see what the original price was. The discount is $3. So original price per book is $26. But understand that?
Yes, sir.
I just work it down to 1 book. I just work it back down to 1 book. So if you paid $46 for 2, it means that he's paying $23 for 1. I just said the same price. And this $23 was after he got a discount of $3. So it means that before the discount, he paid $26. I added back the discount to see what the original price.
You divide the 46 by the 2.
Right. To get the 1 book. How much he paid for 1 book. Then after I say how much he paid for 1 book, I know that for that 1 book, he got a discount of $3. And so I added back the $3 to see what the original price was, which is $26. All right, that is it. Next question right here. It says, at a store, 3 cents in every dollar spent is charged as sales tax. How much is paid as sales tax on a customer whose cost is $196? See, I can set it up again. It's similar to the question we did a while ago. So he pays 3 cents. All right. At the store, 3 cents on every dollar spent is charged as sales tax. All right, so $1 for every $1. For every $1, the tax is 3 cents. Remember, for 3 cents is the put as dollar, 0.03. You're paying $0.03 as tax. $0.03 as tax. So if you get 196, and I can multiply this by 196 for this side to become 196. This is how much you pay for 196. Multiply this by 196 to see how much you pay when you spend 196. Multiply by 196. So really, I'm doing 196 times this. 196 times 0.3. That's what I'm working out. 196 times 0.3. All right, so pick who can work this out. All right, who can work this out quick? I work this out quickly. So I go to the full 196, right? Then go by 100. So $1 is 0.3. Then it means then step it up, but try to approach 200. 196. Almost 200 is enough. It means multiply by 100. It means $100. Your tax will be $3. But it will be $3, right? $3, yeah, $3. I multiply this by 100. Right? So $200, if you reach $200, you'd pay $6. But it's not quite reach $200. It must be the value that is less than $6, which has to be this one. This is the answer for 196. So you can write it here. So therefore, this must be the one for 196. $196 less than 200. $196. So sometimes, guys, I do have to work with the actual things. This is almost 200. So this kind of work it out. $1 give it $3 cents, which is 0.03. And $100 can up to $3. So $200 can up to $6. So 196 must carry to a value less than 6, which is that one. Simple as that. All right. You have to work out everything. That's what the session is about, showing some of the shortcut ways you can use to do the questions. Not everything has to be worked out. The answer is right there on the paper. You have to work out everything precisely. But you cannot use a calculator. If you could use a calculator now, then fine. But you cannot use a calculator, so you have to be able to just, reason out some of them. This one, I think we did this one already as well. And I'll repeat. The value of a plot plan is 18,000 and taxes charged of 0.7 cents. We did this one already, right? And we got the 126. So we have to multiply this 7 times the 56. We have to end up multiply this by this and get the 56. So this was the answer. And we have to multiply the 7 times the 8. So this is the answer. We have the 56, this one. What is the repeat again? All right, let's move on. This one says, Mr. Jones bought a car for $64,000. The car depreciated at 20% in the first year and 10% in each of the following years. So it depreciated 20% in the first year and 10% in each of the following years. So the value of the car at the end of the second year was what? So it's dropping in value now, guys. Dropping in value. So look how we can work it out. We can work it out as what the final value is. So first, after the first year, it dropped to 80%. If you take off 20%, it drops to 80%. So in the first year, it is 80%. 80 over 100 times the 64,000. This is the first year now. This is year one. And then this value now that is in year one. This is the value after year one. So for year two now, you're going to depreciate it by 10%. So it becomes 90%. So you get 90 over 100 times this value. But understand that calculation? But understand that?
Yes, sir.
So basically know that all those zeros wipe out each other. So we really want to be multiplying 9 times 8 times 64 to see what the final answer is. Now the 9 times 8 is 72. So like it's something with that 8 in it. This about 8 in it and this about 8 in it. So I don't want just them two there, right? So I guess sometimes you just have to work it out. Sometimes you just have to work it out. Maybe we could go the percentage route by deducting, but I think this is the easy way to do it. We could see what the size of the number is. So this 0 cancel that 0, and this 0 cancel this 0, and then these 2 zeros cancel 2 of the zeros here. So you're really multiplying 9 times 8 is 72. So you're really multiplying 72 times 640. That's what they're multiplying. 72 times 640. Right? 72 times 640. So you can put the 70 times the 640, 70 times the 640, and the 2 times the 640. But that's what you have to work out, guys. 72 times the 640. And this one is the answer. Because I've run out of time, I just want to push through. But that will be the answer. But that's a good way, good enough way to do the 80% first in the first year, and then in the year 2 now you apply 90% of that value. So you have one calculation through it. All right, you have one calculation through it. So it's 72 times 640. You could maybe do the 70 times 640 and then 2 times 640 and work it out. But this is the answer. Maybe I have to multiply this up to get it. All right. Nobody can do this, right? Nobody can multiply those two, right? I don't have to show you to multiply that. If I have to go step by step. Like so, 60, 40 times 72. Nobody can work that out like that, don't it?
Yes, sir, indeed.
Huh?
Come
Nobody
on,
can do that,
sir, we
right?
can work
Yes,
it.
sir,
Man.
enough
We can work it.
multiplying.
Thanks. Just so I make sure, because sometimes we go like, remember them prep and primary school something. All right. So some of them, the shortcut thing now is a work. See, this question is a reverse of the question we're just doing. So they tell you the tax, they tell you the original amount, and now they want us to tell them what the tax is. It said, plot of land is valued at 18,000. Land tax is 125, 126 charged annually. At what rate per annum is land tax? So you see, this one is going the other way around. So it's 126 out of the 18,000. 126. 126 out of the 18,000 times 100. That's what they're working out. 126 over 18,000. That's what they're working out. So again, you have to just simplify this down. These zeros cancel each other and you simplify it down. Right? 126 divided by 18,000. So 7%. The same question, you know? The same question, 0.7%. This is it. Let's have to work it down. And you could be able to divide this down and get the 7. See that all of them are 7s. You have to actually work it out. All of them are 7. They are all 7s. You have to work it out. All right, but that is it. All right, next one. Exchange rate again. The exchange rate for US $1 is $2.70 EC dollars. What is the value of 450? 450 US. Right? So basically you multiply this by 450. Multiply those two. That's what it's all about. Multiply this times this. Because it is US $1. US $1. Right, that is US to EC is $1 to 270. I want 450. So if we multiply by 450 to get 450. 450. So multiply by 450. Right. And then so it's gonna be the last one. You can literally eliminate these, you know. Can't be that. I multiply these two. Can't be this, because 4 times 2 are 8. Can't be this. So by elimination must be the last one, you know. Can't be this, too small. Can't be this, because it's a 4 times 2 already. Can't be this, again, it's a 4 times 2. Has to be the last one. So by process of elimination, this one you have to work out. You have to work out this one. It must be the last one. Has to be. Alright. Man, I was solid 45,000. Do this one already. So repeat again. Repeat. Have some repeat inside here. That's a repeat. You have to do the tax. I'm going to get the one. I don't remember all of that. But we got the 64 right here. So, yeah, we have a subtract here. So first, we subtract this minus this. You get 32, and then 32 times the 20%. I'm gonna give you the 64 right here. All right, that's it. Next one. A television set costs $350. All right, so I'm doing this one. When bought on hire purchase, a deposit of $35 is required, followed by 12 monthly payments of $30. How much is saved paying cash? So we need to work out the higher purchase price. So this is the cash price right here. So the amount saved is the higher purchase price minus the cash price. So we need to work out the higher purchase price. It's called the HP for higher purchase. It is a down payment of $35 plus 12 month payments of $30 each plus 12 times 30. This is 360 and this is 30. This is 35. So it becomes 35 plus $360. That's 395. 395. So you subtract 350, you get the amount saved, which is $45. So you save 395 minus the 350. It's not even working out, you can see it's 45. That is showing it for the people that the document. $45 to save. Alright. Finishes that. It's now after 4. Alright guys, it's after 4. So we're going to time. It's going to have good lengthy time on this. But there are so many of them. I think it finishes here now. You can just finish right here and then start back here so tomorrow. Right? You can start back here so tomorrow. Let's just finish these and start back here tomorrow. Still have a good number of questions to do. Wow. We have vectors.
Sir,
Yes.
miss out anything because my Wi-Fi chip out, somebody have to wait until they come back.
Well, you can watch a video, so I'll record it.
Okay.
You can watch a video online. There are a lot of questions we have to go through, you guys. A lot of questions. Plenty. But I told you we're doing 600.
Tomorrow we'll do it.
I told you we're doing 600 questions, right?
Yeah.
Right. So I don't think we reach halfway today. I don't think we reach halfway. But I know you guys, you can't do the long stretch like me. You guys can't manage the long stretch. So, but we have tomorrow again and possibly Monday if necessary. I really thought we could have moved faster. Maybe we need to pick up the pace a little bit tomorrow. But we could just finish these on this page. But this will finish consumer arithmetic. And then we can start tomorrow with these. All right? We should be able to go faster with these. And I will come to the last part of the paper. Usually we can go much faster. Questions are a lot easier at the back. The consumer arithmetic is the one that takes the most. And that's I'm going to finish. Mute back your mic, please. Mute back your mic. An annual interest rate. This is a repeat question again. This already. Same question. And an interest rate on a 15-year mortgage on a house is assessed at a value of $450,000, 5 cents for every one. The same question we do. What do we multiply the 5 cents by that? Okay, 225. So this is the answer. We did this a while ago. All right, so this is another repeat. So we can skip over that. Mary invested $200 for 5 years at 5% per annum. John invested $500 at the same rate. If they both receive the same amount of money in simple interest, for how many years did John invest? So this guy can set up a little equation like so. So the interest for Mary equals the interest for John. Interest for John, right? And the interest, as you know, is PRT divided by 100. I already know. So the interest for Mary, the principal is 200, the rate is 5, and the time, no, the rate is 5, yeah, and the time is also 5. So the time is 5 and the rate is also 5. Divided by 100. That's the interest for Mary equals the interest for John. So John invested 500. So John's investment is 500. Same rate of 5 times the time. I divide this by 100. I'm trying to find the time from this. So I just need to cancel down. 100 cancel the 100. This 5 cancels this 5. And then now what happened is that the 5 in this 5 in this 500, 100 here, so cancels this 5. And so we divide this by this 200, and the t equals 2. Because if the up here is going to be 200, if up here is going to be 200, the t has to be 2. The t has to be 2 here. So the t equals 2. Has to be 2. Basically, that's it. All right. So set it up like that and let's cancel it.
I divided the 500 by the 100 or the 500 divided by the 5?
Yeah, but divide this side by this. So
Okay.
I'm go it again. Let's go it again. We cancel it down, right? So the 100 over here, cancel with the 100 over here. We could divide it inside here, so if you want to know. It could come, sorry. So this 100 divide into this, 5 times. And this 100 divide into this, 2 times. Right? Then this 5 on this side. Well, this is 5 times 5 and 5 times 5. So if t equals 2. So maybe that way easier. See it?
Yes, sir.
All right. So anyway, take it t equals 2. Answer is 2. All right. A salesman sells a car for $11,000. If he's paid a commission of 4.5% for the first 10,000, 7.5 for the remainder, then his commission is what? Okay. So you get 4.5 for the first 10,000. That's 4.5 over 100 times 10,000. Plus, the remainder is 1,000. Because after 1,100, of 11,000, you already got commission for 10 years, 1,000 left. So 7%, 7.5 on that. So 7.5 over 100. And that now is of 1,000. That's what we're calculating. That's what we're calculating. Which of these is correct? Let me see. I could work out this one. So these cancel those, and then this becomes 450, right? This becomes 450. Plus, over here now, this cancel this, and this becomes 75. Plus 75. So that is 525. 525. 525. All right, this one. Salesman sells a car, same question, similar question. But instead of these values up here, we have these values down here now, but the same thing almost. Look at it. So instead of 11,000, we have 10.5. Instead of 4.5%, we have 5%. Still 10,000 they're selling first, and 8% on the remainder of 500. So it's a similar kind of work. Let's see what this one comes out to be. Right. So it's getting 5% on the first 10,000. So it's getting 5 over misery. It's getting 5%, 5 over 100 on the first 10,000. Plus, we're getting 8% on the remainder, 8 over 100 on the $500 that is left. That's what we're working out. All right, so 2 into that and 2 into that leaves 500 right here. So this is 500 plus this 8 times 5 is 40, you know, plus 40. So it's 540 is the answer. 540. All right, let's just finish this off. And then we'll pick up back tomorrow. All right, this question says, a company employs 20 persons as gardeners and clerks. The mean daily wage of all employees is $22.40. That's the mean of all the wages. So like you add up the total wage and divide by the number of staff, number of workers. If each of the 12 gardeners is paid $26 per day, then the daily amount paid by each of the 8 clerks is, all right, so we're going to set up an equation like we calculate the mean. Let's set up this way. So the mean would be equal to the total pay over the number of workers, right? That would be the mean. Right? So total pay, we're trying to work out a little thing. So total pay over number of employees, EMP for employees, right? Must equal the mean of 2240. Right? We're not going to put the dollar sign. What is the total pay? The total pay, they gave us the pay for the 12 gardeners. That is 12 times 26. 12 times 26. Plus is 8 gardeners, you know. 8 gardeners, but we don't know the gardeners pay. No, 8 clerks, but we don't know the clerks pay. So it's gonna call that 8x. And divide that by 20, because the total is 20. 12 and 8 is 20 workers. That is equal to $22.40. But that's not a calculation. We're trying to find x from here, so. But understand that?
Yes, sir.
Yes, sir.
All right. So the first thing we have to do is multiply. We can divide through now. We can divide this stroke base by 10 and all of that. You know, divide it out. Right? We can simplify it down first. Divide out this side by 2 and simplify it down. Or we can just multiply the 20 over here. All right? Keep the numbers big. Over that space. You can put it over here. So I just look in what maybe is the best way to do it. Make this a little smaller. Just to shorten the work. All right. So we can divide it down. Divide it down. We can divide this side by 4 over here. So we can divide the numerator and the denominator by 4. So we divide 2 by 4. Right. Divide by 4. And then divide by 4. Numerator and denominator. But divide 2 by 4. Divide this by 4 becomes 3 times 26 still. Plus divide this by 4 becomes 2x. Over divide this by 4 now I get 5. That equals to 2240. All right, then I'm going to multiply this 5. So better I'm going to divide by 2 and keep it at 10. You know? Multiply that by 5. If I multiply by 10, so I'm going to change it. We do it the easy way. We don't have a calculator. We do it the way that we don't need a calculator. So I divide by 2 instead. Divide by 2 instead. Divide by 2, I'm going to put 6 times 26 plus 4x over 10 equals 2240. Multiply this over here, so I get 240. So I have 6 times 26 plus 4x equals, multiply this by 10 over here, so I get 224. This can be divided through again by 2 and simplify it down. I can divide through by 2 again, or divide through by 4 actually. I just go step by step. We can't calculate an examiner. So divide by 2 again. Yeah, divide by 2. Divide by 2, this becomes 3 times, it becomes 3 times 26. That's when we divide this by 2. This becomes 2x. This becomes 112. Divide by 2 again. This becomes 13. In an exam, can't use a calculator. some of them will just have to work out. I can't use a calculator. Divide by 2 again, I get 3 times 13 plus x equal. When I divide this by 2, how much do I get? What am I get? 56. That's right. 56, don't it? That's correct. Hello.
Yes, sir. Yes, sir.
All right. And then 3 times 13, 39, don't it? So the x becomes, match this. So the x becomes, oh man, the x becomes 56 minus this 3 times 13 is 39. X equals how much? 17. But no answer. Any question on this working out?
No,
Any question?
Sir, 17.
Huh?
17.
Yeah, any question on the working out? You understand the working out?
Yes, sir.
So basically
Yes,
set up how we would calculate the mean, right? Put in information, but what we don't know is how many clerks they have. I call it X. But this would be basically the total pay for all the staff. This is the total number of staff, and this is the mean pay. And it's a matter of cancel this down to find the X. That's all it's all about, really.
Sir, but
Just
question, we couldn't
Yeah.
multiply the 22.40 by the 20.
Yeah, man. Yeah, man. You could multiply this over here first if you wanted, you know. And then multiply this to and subtract it, you know. Anyway, you do it, you'll get the 17 same way. It don't matter.
that me get time.
Yeah, man. No problem. It's just that.
Simpler way
Let me-
than for these
let me-
people.
Let me tell you, I'm just kind of doing it in a way to say, all right, we can't use a calculator and we're under pressure and we don't want to working a big number and all them things. You understand me? That's the approach that I'm using. As if you're in the exam and you just want to just do it gradually because you can't use a calculator. You can have to just work it down gradually because we can't use a calculator. That is the point, you know. So if we could use a calculator, then we could have finished this quick. We could have just multiply this cross and subtract this and divide by the 8 and done. We cannot use a calculator. So we're doing it as if to say we can't use a calculator. We'll try to work it with small numbers so that we ensure the accuracy of it. That is the point. I'm doing it as if to say we cannot use a calculator. Because with a calculator, we've done this long time in one line. But remember, we have to do it like we can't use a calculator. So I'm showing you, you could proceed step by step to keep it safe and get the right answer without a calculator. That's what it's all about. All right, the answer is 17. This next question says, Delana invests $5,000 for 2 years in an investment scheme. The investment earns compound interest at 8% per annum. What will be the amount of Delana investment at the end of 2 years? What will be the amount of Delano's investment at the end of 2 years? So he's gaining 8%. Right? All right. So you say one of these two answers, right? There be this, none of these, you know. The amount of his investment, in other words, how much it reach. All right. So what we can do, we can work out what the interest is for the first year, which is 8%. It's compound interest of 8%. Can work out 8% of this. All right. So let's do it. First year. Let's use step by step. And then we're gonna add it. It's after you work out the interest for the first year, you have to add it back to the original amount, you know. So another way to do it is actually work out 108%, you know. But let's do it step by step. Same thing again. Some questions you just have to work out. All right. So we're gonna work out the 8% first. 8 over 100 for the first year. It's called the year one. The year one interest. And we're gonna add it back to the 5,000. It's 8 over 100 times the 5,000. All right, so these cancel these, and it's the 8, 5 are 40. So you get to 400 like this. So this works out to be 400, 8, 5, 40. So the first year amount is, first year total is gonna be 5,400 and 5,400 is gonna be this total. So the year 2 interest now, tell me if you understand it. The year 2 interest is gonna be 8/100, 8% of 5,400. Understand that? That's the interest in the second year. You have to add now this interest to 5,400. So it's new figure. It's new figure. After I reach this, so it's new figure, it's new total. It's new total. That's right. The new total or the compounded figure. The new total is gonna be $5,400 after the first year. And then you're paying the interest. Now you're gonna add the interest on 5,400 and add it to it.
432, sir.
How much?
432 when I'm working.
It's gonna be 232.
432, sir.
Oh, this is gonna be 432 now.
Yes, sir.
All right. You say that this is gonna be 432. 432. I'm gonna add the 432 to this now.
You get
So
5,
new
8,
figure in year 2 is the last one. So it's a new total in the year 2. It's gonna be this plus this, which is the 5,832, which is the last answer. This one. All right, that is it. And that finishes these questions. All right. It's now 4:30. I'll go half an hour over. So tomorrow, I'll show you which page 70, which page 17 of 61 pages of work. We might need the third day, but these questions are supposed to run faster through these questions that we have next to, right? Let's give you a quick glance at them before we end the session. So I have all these questions to go through. Some algebra-like questions and so on, right? Some indices and stuff. And so we can run through these questions a lot quicker. Right? I'll go through these questions. It takes less explanation. So we should be able to go much faster through these. And there are a couple of repeats in there as well. So hopefully tomorrow we can push it. We're going to go to matrices. This is matrices down here. And then matrices, all of this. And then we're going to go to vectors. We have all these vectors questions. Right, vectors, which also we can run through these quickly. I think we're going to go much faster tomorrow because the consumer arithmetic is the one that takes up a little bit more time. All right, so these is pretty straightforward. We'll come to these measurements question, volume and so on, area, trapezium, right, which are all very similar. We'll come to some polygons questions, few polygons questions, some circular measures, easy again, come fast, circular measures, and some more measurements, area and perimeter and so on, some mensuration questions. Right, yes, and then we'll come to some statistics questions, similar. Statistics, I'd say statistics. I'm showing what we're gonna do, you know. Statistics. Let's see statistics. And then come some coordinate geometry, some functions. Functions. Analysis functions. And then comes some transformation, and then we'll come up to the end. See, like I have one question and 2 questions on a page that are similar, so much faster down here. And it comes to pure trigonometry, some simple basic trigonometry, and over there. All right. Looks like a lot, but we can move faster quick tomorrow. We move faster tomorrow. All right, so I want to start back tomorrow on page 17. Page 17. If anybody have any particular topic that you want to go first, and let me know. So instead of doing these algebra questions, somebody might want to say, you know, do the vectors first or do the matrices or the transformation first, whatever. So I'll oblige, no problem. There's still a lot of questions to go through. 600 questions we want to do in about 2 days. So we need to pick up the pace tomorrow, guys. Pick up the pace. I'll move much faster tomorrow.
All right, sir. Tomorrow.
And if necessary, we can come back Monday. What time Monday? What time Tuesday is the exam?
Sir, 9 o'clock, sir.
Okay, so we can't go 2 days. So if we're doing anything on Tuesday, on Monday we have to start kind of early. We're doing anything Monday, so we can finish. But we can push tomorrow and see if we can finish it tomorrow.
Tomorrow.
All right.
Yes, sir.
Bye, everybody.
Yes, sir.
Bye,
Tomorrow.
sir.
Later, sir.
Yeah, man, sir. Tomorrow.
So tomorrow, 11.
Yes, sir.